I feeling, but still like.
Hang on one sec.
Hey, how are you?
Nice to meet you in person.
Good.
Yes. Nice to meet you. I'm Katie. Nice to meet you.
Nice to meet you.
I'm Katie. I'm Katie. Oh, nice to meet you.
Yeah,
nice
you
to meet
too. Wonderful. Thanks so much for coming.
Yeah, of course.
Making the presentation.
Thank you. So excited.
Yeah.
This is
Do you
really
need to
interesting.
hook up your laptop?
Oh, sure.
Yeah, you can just get that set up.
And
you said we want to do Zoom.
Same.
Yeah.
Yeah, I know,
Yeah.
but I just want to make sure
So-
she's set up.
Thanks. Yes. And Josh might be closer to 6:30 than 7 actually. So he recommended we just go with the talk and then start discussion. The talk could also extend to an hour and a half if needed.
Okay.
So.
Okay.
Okay, wonderful.
Hello. See, this is exactly what I'm talking about. I have to run to the restroom really quickly. Hello.
I'm Katie. Nice to meet you.
Katie, the first
Yes.
presentation.
Yeah. Well, second presentation. I'm going first.
Oh, the second presentation. Forget it. Let's see.
If Scott's presenting first, would it make sense for his to go first? Or mine?
I'm not sure if you have slides.
Okay.
But let's test it out to make sure there's no glitches.
Yes.
Hey, well,
And change one slide.
Yes, I think it's
did you say
Number
there's
one,
some people
number
on
one.
Zoom?
Yes.
See?
okay. I would like.
It's already.
Oh, you already saw
Yeah.
that.
Necessarily, I'm like,
So, you know how to do the Zoom thing? Okay, I will.
I appreciate your help.
Yeah, we just want to make sure the video is also on. So how does it work? Oh, there are two participants, that's great.
So you're, you're here now.
That's mine, actually.
Oh, this is your note taker?
Yes.
Okay, cool.
One or two.
Okay, do you want to connect it real quick to make sure
Sure, yeah.
everything, and I'm gonna join by Zoom to
Do you
just make
have-
sure.
So, just double check.
I think it's really helpful, or I can use my computer for.
Yeah. Maybe the way to have it.
Always nice.
Oh, hey, Seth, how are you?
Hey, Seth.
Okay.
What's the meeting?
Andrew, good seeing you. Okay. It's okay. I'm gonna go first.
Yes.
Do you have slides?
Yes, I do.
Oh, okay.
I'm gonna like review
Okay.
because I realized we had a bigger group that has no idea what we're trying to do.
This is super exciting, isn't it?
It's any group that grows in size.
Where's Caleb?
We're like COVID. We're like tariffs. Number go down, Charlie, number go down. The, Eric, can somebody throw that in?
Oh, yeah.
Okay, and then let me, it's okay, I'm gonna steal
Yes,
that.
yes, yes. Do you need a clicker?
Yes, and also. So I realized that we're getting new people and, hey Otter, what can you, here we go. Let's see, did we end up with a clicker?
To record meetings, generate transcripts.
Why don't we go around? So, okay, so first, everyone, welcome. You can say welcome too.
This is very exciting. I remember the first time we met about, tinkering around this reading group, and we had no idea that by the fifth session we were gonna have so many people
Yeah.
around the table. This is very exciting. Welcome to the reading group.
So why don't we go around really quickly, because very often I'm in rooms where I know everyone, but not everyone knows everyone, but in this one, I don't even know everybody. So I'm Scott Stern, I'm a professor here in the Innovation, Entrepreneurship, and Strategy.
Hi, I'm John Horton. I'm a professor here in the Information Technology group.
Roma, first year PhD student in the marketing group.
My name is Seth. Seth John. I'm a third-year PhD in the Brain and Cognitive Science department at MIT. So working with Josh Tanlum and Roger Levy. So I work in the intersection of like AI, NLP, and cognitive science.
Charlie Fine, I'm a professor in Sloan School in Operations Management Group.
I'm Oh, sorry. I'm Zara, first year PhD student in the Information Technology group. I'm Joey. I'm a second year strategy unit PhD student at HBS.
I'm Paul. I'm a third year PhD student at HBS operations. I'm Josh, second year PhD student in the marketing group.
I'm Matin. I go by Matt. I'm a third year PhD student at EECS. I work with Vikash Mansinka and Josh Tenenbaum, that sort of thing.
Hi, I'm Rahul Bui, faculty in marketing here, working in the middle of computational cognitive science and behavioral economics.
Hi, I'm Vansh. I'm an incoming student at TIES.
Hi, I'm Naiman. I'm a PhD graduate student in
Hi everyone, I'm Luca. I'm a PhD student here at TIES.
Amir Sururi, I'm a visiting scholar at MIT TIES Group and assistant professor at Purdue University.
Hi, I'm Angie Moon. I am second year PhD in transportation, and I love both Bayesian and entrepreneurship.
And I'm Katie. I'm a PhD student at the other Cambridge in England, but I work very closely with Josh Tenenbaum's group, and I'll be starting a postdoc here next fall with Josh and Tom Griffiths.
Congratulations. Well, that's okay. And who is the last person here?
Ocean real estate development.
Okay, very good. I believe that this might be the most, we pride ourselves on MIT being a fairly interdisciplinary place that mixes different groups and whatever. I believe that we might not get much done in the next hour and 45 minutes, but we're actually achieving at least the first goal of at least all being in the same room at the same time. So I'm giving that. I also wanted to thank Amir as well as Angie for helping set up today. Amir through the leadership of all this and Angie on this particular session. And here we're gonna have Katie in just a little while, and then we're gonna be joined by Josh Tenenbaum in a little while, who's doing this and to be honest, there's just, this fascinating body of work that Josh is well known for that I think we're going to hear a little bit about, but there's sort of these increasing strands of potentially linking the kind of decision-making we like to study as scholars of entrepreneurship in related areas and management and the kind of work that Josh and his group are doing. Is everyone so far so good? Okay, what I thought I would do, and I'm literally the case that I have a gajillion slides, so I'm not going to accomplish this, is there's one more piece. I believe it's the case that the one thing that we haven't accounted for is that Josh is not going to be able to get up into this floor as of 6 o'clock. So somebody needs to text him or something and meet him on the first floor at the appropriate moment in time.
And I just heard that he's not going to be able to make it until after 6:30.
There's high uncertainty over when he'll actually.
Oh, okay. So he will come when he comes.
6:15 and 7.
Okay. So you're going to talk until you talk. Yeah. Then we can talk again, and then he will join us for when he does. And it's going to be great to have him here. But the one thing I would add is we have to make sure he can get into the room, and I have no idea how to do that.
I can text him.
Okay, great. Okay. So what I thought I would do, because I think most people here are vaguely aware of this, but I'm going to go a little bit back and do. So this is the 4th or 5th meeting of this group. Fifth meeting of this group, and I wanted to give a little context of why we're here. And I'm going to be very honest in what I'm going to do a little bit of summary of what I so far have learned. This is not a complete summary because I don't have a lot of time for it, but also it's hopefully to bring those who have been coming on a regular basis to say, oh, we got to this level. And for those of you who are new, to give a little context for the rest of the evening. Does that sound like an okay plan? And I'm going to go really fast, but hopefully with some purpose. Okay. So let me just tell you why we are here, because this is a useful one. This is Ken Arrow, one of the great economists of the 20th century, and we organized a meeting about 15 years ago, Josh Lerner and I, in memory of the 50th anniversary of his famous article about the economics of invention. Ken talked at the event, and he came up with this quote: "Any theory that purports to explain novelty is intrinsically paradoxical." And remember, this is Ken Arrow talking, not just some rando. How can you have a theory of the unexpected? If you had a theory of what novelties emerge, they would not be novelties. And the way I remember Ken said it at the meeting was that if you think you have a theory of the unexpected, you're a theory of innovation, you haven't thought about the word theory or innovation hard enough. That was very apt. Nonetheless, we're going to try to make some progress here, and specifically building on a wide variety of work that some of you are more or less familiar with. What this group is, I think, organized around is the belief that the following 3 things, which have been mostly studied in isolation, all can have a unified cognitive or behavioral framework that links them, and that in fact the linkages between them may in fact yield interesting insight. One is that entrepreneurs are pursuing ideas. Those ideas might be created in some well-defined social sense, or they might be discovered, but they believe in what they're doing. That is my observation about entrepreneurs. But they're not like completely stubborn and immune to all evidence, or else they'd all go bankrupt, right? They also somehow engage in some level of learning and experimentation to learn about and refine and figure out what parts of the idea work or not, and surface different ways of undertaking then a concrete plan to turn the theory into the action, making the startup that hopefully then all of a sudden you go off with your riches and live on a yacht. Everyone so far so good? Okay. Within that framework, we didn't invent, you know what I'm saying? Those are some good graphics, but I don't think we invented understanding that those things would occur. This group is not only motivated, but largely motivated by one insight, which is the fact that the entrepreneurs choose the opportunity they pursue, which says they must believe that it's not a terrible thing to do, right, might impact how they experiment things, how they interpret evidence, how they attract resources to the firm, and how they pursue strategies in a given domain. Is that a fair? Some of this is review. Okay. Okay. So, let me do this right. So, that once again, well, let me do this one just because I think this is a useful, right? So, just to be clear, one of those natural settings for this is Shark Tank. Okay. So so I'm going to put on my strict economist hat for a second. I was actually just in a group with economists over the weekend, and they all agreed that my view on their perception of this is correct. These shows where they show pitches have the following feature. Some people come out on stage and they tell some group of experienced investors and people about the idea. And then the person says, basically, should I go forward with this business, and what should I do? And then amazingly, the group of so-called experts disagrees with each other, which has the feature of being an extremely natural thing for human beings to do, and is essentially assumed away by most economic theory. Just dead stop. You know, if you teach baseline economics, and you give out, if the person came out and said, I have the monopoly pricing problem to solve, here's my demand curve and here's my cost curve, this group of supposed experts should all agree on one answer, right? Do you see what I'm saying? Right, the idea that, right, so in other words, they're not being asked about their preferences, they're not being asked about, like, you know, what, you know what I'm saying? They're saying, for this entrepreneur, what should they do? They should sort of all agree on that. And the whole reason we like Shark Tank, for those of you who like it, is that we disagree. It is not unique. It's obviously a nice tension of pitch, right? But it's inherent to the world of innovation and entrepreneurship, right? Whether or not it's the venture capitalists doing the humble brag on, you know, these are the ventures I passed on, whether or not it's Catalina Carrico basically being drummed out of academia because she had exactly the right idea about how to stop pandemics, or amazingly, as Luca and some others have really dug into, the fact that people literally didn't believe the Wright brothers could fly for like 5 years. It's just absurd, right? And, you know, I don't like Peter Thiel on some political stuff. That's off the table for today. We'll talk about that in a few weeks. But on this, I think is a pretty good question. This is the lens that he, a leading venture capitalist, uses to filter, are you the right kind of person for him to invest in? What important truth do very few people agree with you on, right, as the basis of the venture? Does that kind of make sense? Okay. You know, there's lots of other things we could do here. And so thinking like that led to us to try, a group of us, along with our colleagues in Bocconi, some up in Toronto, to try to think about this more carefully, which leads you on the one hand very naturally into thinking about this great, you know, worlds of how entrepreneurs experiment. Here's this great article by Murray and Tripsis that sort of organizes this. And the whole thing is that they point, this is as late as 2004, they are, I think correctly, the idea that you're learning through purposeful experimentation as a startup was effectively a new idea in the academic literature as of 2004. This article is cited, several hundred, if not 1,000 times, because it introduced that concept to the academic literature, right? Along with Aaron's not here, Aaron and myself and Josh, right, in our recent textbook around entrepreneurship, we have this whole framework that's quite well developed about, how well developed it is, but it's developed, right, that kind of talks about the requirements for learning and experimentation, right? But then the question is, how does that process of learning, experimentation, process strategy, how is that influenced by the fact that you're like, oh, you might not be optimistic in general, but you're optimistic about this. I'm gonna take only 5 more minutes if that's okay, and then we'll chat. Any questions so far? So far, so good, everybody? I know some of you are like, we saw this before, but okay. So what are we trying to get at here? So I'm gonna claim that we're gonna introduce 2 key modeling elements to define this kind of domain that we call Bayesian entrepreneurship. And Luca and I worked with Alfonso Gambardella on a paper recently that sort of kind of synthesized exactly this piece, less technically than the longer essay we wrote with Aaron and others. One is breaking the core economic assumption and allowing for subjective and heterogeneous priors. We had a great discussion a few weeks ago on that one topic, and we're going to revisit, right? And then secondly, but also saying that we're not only just going to allow for subjective priors, we're also going to allow that person to be basically a believer that they can learn about the world and revise those priors in some proactive way, and that's going to lead to a demand for experimentation. So far, so good? Okay, so what do we mean by all that? Okay, ready? So one is, I want to sort of say, so we had a really good discussion a number of weeks ago here, and it prompted me to go back and read a lot of things and whatever. So one thing I've taken from this broader reading group is there's 2 things. So a lot of people complain that economists basically insist on shared priors in almost all game theoretic economic modeling. Okay, there's a great article by Steve Morris that we read a number of weeks ago that I think kind of lays out that argument for why it's important, why it's occasionally a modeling device, and when it is appropriate. That's very helpful for people interested in this question. But it's not simply a convenience. It really is quite deep. And the key insight is, if you're claiming that you're going to study people who are vaguely rational, then if I get a different signal than Charlie, and then we trade our signals, I don't know, we should do a lot of updating to now have shared priors again. Do you see what I'm saying? So unless there's an agency issue, or I think Charlie's trying to screw me over, where do we get it? Do you see what I'm saying? And just to be clear, I'm not going to go back to my whole thing on the Umwelt. Highly recommended, the zebras and the whole thing. But let me clear, you have to have a pretty good foundation for what you believe about where these subjective priors come from. And what I would say is that one thing I've gotten from the last 2 months that I don't think I could have said in January is that probably the leading candidate is the idea that in a way that I think psychologists and cognitive science definitely have models of, right, is that human beings are walking around with any number of theories in their own heads. But until John and I face a situation, we don't even know to ask each other, what's your theory of, oh, it's snowing in July, which I guess is wrong for climate change, but you know what I'm saying, right? It's snowing in July. What's your theory of that? Well, we've never encountered it before. So it's not surprisingly we have different theories of the case. And it's not like a transfer of one signal. It would depend on me basically living John's life the whole way. And since we're only one human being in one little vessel on this big blue earth, there you go. I'm not going to, I wouldn't mind living John's life, but you see what I'm saying. Right, exactly, right? And in particular, that leads to different theories of where value is created, different theories of parameters, different theories of what might be the right thing to do. Okay? So one thing where I would suggest people who are interested in this space might think about is the idea that subjective priors they shouldn't just be assumed like, oh, we allow for that, because then you're basically throwing away any sort of rationality. But new situations are not a bad place to think about them, and you have to ground them in something like shared disparate theories. That's okay, great. That, it turns out that one insight leads you to a group, and this is basically now replicating a little bit what we learned. This is a bit of a rewrite from what we learned from Ruka. One is that the overlooked but nonetheless important insights of Eric Vandenstein still hold, right? Is one that basically there's nothing about being overconfident about what you're doing in life that makes you irrational. It just makes, as long as there's no disconfirming evidence, don't be so convinced. And moreover, that has a direct implication for who joins your firm and what resources you attract. So if I walk into a venture capitalist office, the one thing that venture capital, right? So John's the venture capitalist, I walk in, the only thing, so as long as he's not Andreessen Horowitz or Peter Thiel himself, the one thing John knows is those other people said no. And so what would lead him, right? And under like any theory of shared priors, he should therefore say no. He doesn't need, it's a summary statistic. But why does he do it? Because he shares the same crazy views I do. Sometimes we're right and sometimes we're wrong. You see what I'm saying? But the third is that the degree to which you respond to information when you have subjective priors is quite different. So this comes from Luca's paper, was the idea that here this contrarian researcher does an experiment and makes themselves kind of like even more confident in their thing. There's a neutral party and a person who totally disagrees with them. And the nice insight from this model is you can attract the kind of neutral investor without attracting competition if you're a contrarian. Because when you update positively, the investors update kind of over a threshold, but these guys are so against you, they're like, probably luck. You see what I'm saying? I think that's a really nice insight that directly comes from this. Everyone so far so good? Okay. Second, we learned a lot about proactive learning. Once you could go through that, there's lots of other literature, but so we have this little framework about here's Bayesian entrepreneurship, right? Is this framework gives you that depending on your subjective prior, you're going to have a demand for experiments. The demand for experimentation is, I think, the idea that different people for the same opportunity would have different demands for, without pushing, and I even said this in this talk I gave last week at Pitt and CMU, I said about your work, that would have been a very useful frame for your like, it's already nice, but I don't think you were thinking of it in this way. Right, so here's like a paper published this year by a very smart person who's interested in this area, but the idea that like different people looking at the same idea would emphasize experimentation over implementation versus just give it up, I think is a new and novel way to think about these things. The more subtle piece comes from this technology of basically biased learning that Josh Gans sort of developed for a whole other set of papers and now is being adopted here. And basically, let me just kind of go to the punchline. The key insight here is that once we have subjective priors, there's literally no thing as unbiased learning. And basically, even the simplest experiment where you're extracting you're basically getting a signal that basically has type 1 and type 2 error. Unless you have unless you're so lucky to have an experiment that's completely discriminating, right? You only get good news when it's going to be a success and only get bad news when it's going to be a failure. The proportions between how much type 1 versus type 2 error you have is essentially built into the kind of experiment you built. And specifically, there's just a very nice insight, which is that if you're currently optimistic, you basically are going to completely eliminate false negatives. And for a skeptic, you're going to try to eliminate false positives, because those are going to be most informationally informative about where you are relative to your prior. Does that kind of make sense? Look at that, John was agreeing with that. And that's new to you, right?
It is new to me.
And it's like a very interesting insight that has many implications. Okay, and just to be clear, those implications are not simply like we can do more research in this area. They help you think about whole areas of the literature in a new way. For example, right, if you think about the classic endless debate between should you try to get the hardest people in the industry, the most influential people to adopt first, and they're influential on others, or should you try with people that no one ever cares, the incumbents literally hate and are happy to see go, but at least they'll love you, right? That's a big debate in entrepreneurship land. Well, that's exactly the difference between one of these low bar versus high bar experiments. Do you see what I'm saying? Right? This says if you get this to work, the whole thing is really likely to work, but actually the effort you put in, it doesn't like it might have worked anyway. Do you see what I'm saying with right? It could fail, you could get bad news because that's really hard. You know what I'm saying? And this one, right, in this, sorry, no, I got it wrong. Blah. You see? That's too long. In this one, you put your best foot forward, so it's hard to get them, right? But if you do get them, you're putting you put all your effort on getting this one kind of customer. The advantage is the targeting the best lead users, right? The good information from that is you get no false negatives. In the lean startup, sorry, I just misspoke as I was going, was that you get very few false positives, but you probably get a lot of false negatives, which leads the optimistic entrepreneur to be honest, persistent despite evidence against them, right? Which is, I think, very grounded in the phenomena, and leads other people to be, no, your minimum viable product failed, we're pulling the cash from our venture fund. Everyone so far so good? Okay. So lots of other things to do. I'll distribute these, but one is that one of the things I've been able to do, just really, and I credit the group as we do this, is there's these other adjacent views in the strategy, innovation, entrepreneurship field, such as the theory-based view from Todd Zenger and Teppo Fallon. That like a year ago or even 6 months ago, I would say they were in opposition to this approach. And now I think we have a really clear understanding of where this fits in. We might have disagreements on the margin, but it's much more clear that theory provides a foundation for subjective priors, and that's a very useful thing. And it's not in opposition to having a Bayesian approach to entrepreneurship. Similarly, I had an opportunity to be at a pit where Sharon Alvarez is much more kind of qualitative, kind of conceptual researcher in the strategy entrepreneurship field. And we sort of talked a little bit about how this fits in with her approach as well. Finally, here's nice work by Luca. Just to write, I think your dissertation, as well as some of the others that are running around, but yours in particular, is the first really empirical exploration that's at scale. And once again, really showing that this contrariness has some implications, in particular that even very public demonstrations of the impact of contrariness is a spur on the way into venture creation and success, but interestingly is not a spur to as much competition. Is that a fair summary of what you discovered?
Sure, yeah.
Okay, next Monday, your dissertation defense, we'll see if that's enough. Okay, so sorry I went on for so long. I hope that was that a helpful summary to start out this meeting? Does that help?
Yeah, very helpful.
And so the idea now is to try as much as possible to kind of pick at these various tools in the very rapidly emerging world of Bayesianism, of different approaches of using different constructs of Bayesian learning and using what we're going to hear about intuitive game theory to kind of say, can we use those tools to directly apply to studies of the domain of entrepreneurship? And with that, Amir, I'm not sure if you want to introduce Katie before we get started, but why don't we shift things over?
Thank you.
Absolutely. Katie, you're visiting us from Cambridge,
Yes.
and you're visiting Josh Tannenbaum, right?
Yes.
Okay, wonderful. We are very excited to have you. Thank you for preparing your presentation.
Thank you.
Yeah, the floor is yours.
Thank you. Okay, let me make sure this sets up.
Oh, look at this.
Okay, great. And then consent.
Perfect. Gintis. He must be.
He's, yeah.
He passed, but not long, but not that long.
No, maybe last year or so.
I only met him once.
Same here. Bill's a big guy.
Yeah,
I mean,
I think
Amazon
I told him,
too.
said I told him you might
Right,
text
right,
him.
Amazon.
You're texting him, okay. Okay.
Tell me if he's here so that I can.
Okay, yeah.
I think it'll be closer to 7.
Okay, great, yeah, that's
Okay.
it's all gonna work out.
It's loading.
Yeah, and maybe just to do one piece before the frame is, so as Katie gets started, so one of the interesting linkages here is with taking much more seriously the idea that there's a linkage between this work on this side, like, I wouldn't say this side of campus, but sort of in this building, and kind of work, I think, that more seriously, well, more serious than me, for sure, because that's the bar, really kind of addresses and thinks through the behavioral foundations and what real world decision makers and what human beings are capable, both through the lens of cognitive science as well as, I would say, computer science. Is that a fair starting point? Okay.
Yeah, I'd say cog sci plus CS.
Okay, great.
Yeah.
Welcome.
Thank you. So I'm Katie. We'll be talking about humans as an intuitive theory of games. I know many of you might have read our paper that we had at CogSci last year, which was co-led with Said Zhang. We since have some new results that we will be showing today, as well as some other work. So very excited to talk to you all today. I think, Scott, your talk really leads off into people's priors that we'll be talking about here. So one of the reasons that I'm personally really excited about entrepreneurship and talking to you all today is that humans love to create new businesses. And so much of human society has been around business creation, from some of the earliest businesses that were created back in the 500s around construction companies, to textile companies in the 1100s, to then a suite of new clothing and apparel companies, from New Balance, Adidas, to Nike. Humans have kind of created companies for essentially all the time that we have been around. Even young kids create companies. Raise your hand if you've ever created or run a lemonade stand when you were growing up. Or if not a lemonade stand, you kind of started your own business in some other way. Maybe not all of you. But it's very common for kids to create companies, try to do something, try to build. And even today, there's articles pretty much every other week, every other day, that there's new companies that are being made around AI. So humans love to create companies. And that's one of the threads around us. Moreover, as Scott was saying, we don't just create companies, we also decide what companies to invest in, what companies to spend our time and effort. Shark Tank is a key place that people are showing how they're deciding or making choices. If anyone's heard the All In podcast before they got as political too, there's a lot of talk about how to invest, how to make choices. Which people choose to invest whether or not they're experts in the area that they're choosing to invest in, say GameStop, the GameStop frenzy. Even in kind of everyday life, you might decide whether to give your friend money to start their venture, depending on kind of weighing the trade-offs of risk and reward that they're taking on. And even friendships can go astray related to choices around where and how to invest. We don't just determine or kind of decide to create a new business or determine where to invest our money. We also decide how to take action to fulfill our goals once we have a company. So say OpenAI right now might be thinking, should we open source one of our models? How would this decision relate to our goals, push forward our goals of building AGI first? And how does it relate to, say, blocking the goals of our competitors? If we open source our next model, how does that relate to what others might be doing? Further, we also can decide how to take action in light of new systems of rules and reward that change. Say, with tariffs, companies are needing to deal with new changes to the rules and structure of our economy. We're kind of endlessly creating and investing, deciding how to spend time in systems of rules and reward. So what this talk will be about today is how games can offer a compelling window in which to study decision-making, creation, and overall action in systems of rules and reward. And I'll pause briefly to just say that Mao is another co-author who just came in. Mao is an awesome MN student in Josh Tenenbaum's group who is also involved in this work. So games will be the lens that we'll think about business through in this talk. And as with businesses, we love to think about games, and we have for centuries. And we don't just love to think about games, but we also love to get really good at them. People spend a lot of time to get really good at chess and things that might not necessarily have value right away, depending on your view on chess and certain games. So a lot of the focus on how to think about games has focused on that latter part, on expertise, how it is that people become experts in an area. A lot of older CogSci work back to the 1950s and 60s focused on kind of what we could learn about human cognition through studying experts, of kind of tracking experts' eye movements and seeing what that could reveal about how we value new situations. And that's gone on to recent work in Nature and other venues to look at kind of how people's depth of planning changes as a function of expertise. These studies of expertise have gone on to inform AI, thinking about how we can build systems that could, say, be superhuman in chess or in other games like Go, where, again, the focus has been mainly on experts, on how experts develop what happens when you become superhuman or kind of top in an area. But entrepreneurs often don't start off as experts. When you're entering a new field, you might be a novice. And we can think about this kind of like how we might play new games we've never played before. And there's been much less work in cognitive science that's looked at kind of how novices reason about new games, new systems of rules and reward that we've not before. And that'll be the focus of this talk and hopefully launch a discussion of how we go from novices to experts. So this talk will be structured around 3 prongs. First, I'll talk about more of the work that you might have read if you read our paper of how it is that we decide whether a game is worth playing that we've never played before. And we'll talk about how this relates to a theory that we're putting forward of kind of intuitive theory of games and the data set that we designed to study this. Then I'll talk about new, never before shown results that we have looking at how people decide to take actions in games they've never played before. And then at the end, we'll talk about creation, depending on time, of some ideas on how it is that we might create new games that have particular goals, which could tie into, Scott, your points on innovation. And Angie, at the end of this, we'll have some probabilistic programming points, if I know you're interested in that. I'll pause here just to see if anyone has questions on the overall setup before we get into some of how we're actually going about thinking about new systems of rules and reward.
And so let me just ask you one question, which is, and by the way, I love the paper too. There's very rare I enjoy so much paper on a Sunday. Right? So these questions are sort of slightly different. Like the expertise literature has its role, and I'm wondering if. But for this talk, I should think you're sort of abstracting away from the value of expertise and how the value of expertise would itself affect these questions.
Yes.
You see what I'm saying?
Yes.
So I sort of think, I mean, there's the great, so Steve, you might or might not know. So Steve Levitt had these very nice papers on, there's these, which we can maybe talk about after, on penalty shot taking in soccer. You do that, right? Where he shows, right? And then there's another set of papers on tennis. Right, where the sort of penalty shot taking is, are you an optimized penalty shot maker? Is kind of, there's a nice game theoretic implication, which is basically the probability of going to the left, the right, or the center should be the marginal returns to the rewards of that for any given goalkeeper, kicker pair should be equalized. But guess what? When kids play it, they don't equalize it, but Messi apparently knows how to play. Do you see what I'm saying? So that's like a game theoretic expertise point. Do you see what I'm saying? Yeah. So, okay, maybe we'll come back to it as
yes, that's a great point to set up though. So we'll be focused on novices, how people play games they've never played before, but you could also be an expert at some game and then you're encountering a new game, which we could argue that depending on where the economy goes in the next few days, weeks, that people might be more like novices in these kinds of realms where you're making decisions under new rules that you've never encountered before, which ties into your point before about kind of adaptation. So that'd be the focus of this. And it's not saying that expertise is bad, expertise is awesome, but there's been less work studying novices, and the perspective of looking at how people play, act, make decisions in new situations, new games, might be more like some early stages in entrepreneurship, depending on how much someone is thinking. So the first question that we'll focus on is, how do we decide whether games are worth playing at all? Before we get into this, I want you all to think about the game where you're playing 3 pieces in a row on a 5x5 board. Now, before this, raise your hand if you've ever played tic-tac-toe, or noughts and crosses if you're in the UK. Okay, great. Who has played 5x5, 3 pieces in a row? I know Seth and now have, but other than no one else. Okay, great. So would anyone like to suggest where they would move first if they've never played in this game before? What point would you choose? Middle? Okay. Oops. Imagine that you're thinking about this to then kind of make an assessment of how fun the game would be to play. But let's say you said the middle, so yes, you might go in the middle. Does anyone want to suggest where they would go in their second move?
Corner.
Corner. Okay, interesting. Other people might go kind of nearer to the center. But this is just get you all thinking about how you might play. And you might be kind of thinking about this when you're trying to decide, say, whether this game would be fun to play or how you might expect different outcomes to go. So say you might then, someone else might go here, someone else might go here, and then someone else goes here. So if you then kind of saw this playthrough of the game, or you imagine this playthrough, would you say that this is a pretty fun game to play of this class of games?
Whoever goes first wins.
Yes, yes, yes. So then you might update your belief, say, about this, how fun this game would be, even after just seeing one observation, or maybe some of you in the audience are pretty good at knowing that this would be biased, and then you think that it's not a very fun game to play. So this is one of the questions that we were very interested in asking, of kind of how it relates to whether you should spend more time learning this game. So maybe if you say, this is not a very fun game, I don't want to spend any time learning how to play this because you can just win if you go first and you're playing a regional opponent. Would this be a rewarding game to bet on? Probably not, unless maybe you're watching kids play who don't know the optimal strategies, whether it's fun, and should you become an expert? Kind of, these are questions that depend on how you think a game might unfold. So what we propose is that there's actually, people have intuitions, kind of underlying algorithms, computations by which we can make these assessments of whether a game is likely fun, worth investing our time in, by predicting the expected outcomes. And we're very interested in kind of how we can model this computationally. A lot of computational cognitive science, for those who might be less familiar with the field, is about building computational models of aspects of human behavior and cognition. So we're very interested in two questions in this first work. How it is that we get started playing games we've never played before, and how we can evaluate new games even before we started to play them. So to go about asking these questions, we needed a big data set of new games that had not been out there so that we could explore how people reason about these games that they'd never encountered before. This is huge credit to SED, who essentially came up with 121 new games that varied in board size, so say 5x5, 5 pieces in a row wins, 4x7, infinite boards. They had varied game dynamics where, say, one player could go twice on their first move, another where the second player could go twice, third, and different win conditions where, say, it's not actually 3 in a row that wins, but 3 in a row loses, whoever goes first, or whoever gets that first, or that only diagonal wins are allowed, no horizontal, or that players have different number of kind of pieces that they have to win. So there's a big data set that we have that we're very excited by that has games ranging in all of these properties that people and models like LLMs wouldn't have seen before. And this allows us to then study people's evaluations in play in these games. So what we ended up doing is taking these games and asking 3 different intuitive theory of games queries. One, how likely it is that these games are to end in a draw, and we asked people and our models. 2, if the game does not end in a draw, how likely it is that the first player will win. So that can give us a sense of any person's predicted payoff of the game. And then how fun this game might be to play. And this latter question in particular, I think is a good place to also study disagreement, as you were raising, Scott. Yes?
What kind of assumptions are people making about who they're playing against?
Great question. We explicitly tell people that they should think about a reasonable player, but as you'll see in some of the later results, people vary pretty widely even in their abilities on a new game. One running joke within our project is that I have horrible intuitions on some of these games. I really struggle with grid-based games. Now and SED are actually both very, very good. So people differ even in their baseline quality of how they play any one game. So we tell people to think about a reasonable player, but not everyone is a reasonable player.
But 2 reasonable players, right? That is...
2 reasonable, yes, sorry. For here, it's 2 reasonable players, and then we'll show some later results where people actually play these games and they're thinking about likely the other being reasonable. That's a great question. Any other questions on this setup? Great. So the interface looked essentially like this. We told people, we gave people 10 different games, and they were given one of these 3 questions, or one of 2 questions. We asked either about predicted payoff, so those first 2 questions together, or about funness. They saw a game, and we gave them an interactive board like this, where they could then kind of click around on the board to kind of engage with or externally simulate how they think the game would unfold, and then they could indicate how likely it is they thought that it would end in a draw or not. And we saw that on average people clicked about 9 times on the boards, but that's kind of collapsing a lot of the variation, that some people were quite heavy clickers of kind of using the board to imagine how they would think play could unfold when they were trying to make these judgments, and others didn't even touch the board at all. People then spent, on average, about a minute and a half to reason about these questions. So now, before getting into the results, I'll tell you about the model that we propose people have when they're thinking about these games. And key is that we are proposing a spectrum of models, thinking about a spectrum of models. Like you were saying, not everyone is the same kind of novice or has the same experience when they come to one of these games. So we're interested in a distribution or a family of these models that could capture generally how people are reasoning and later on playing. And the two key axes that we're thinking about when we're modeling is how far ahead is someone searching, and then how do we actually choose these moves to search over. So a lot of the work in kind of the AI space had looked at kind of searching to the end over random or learned features. Say that's how AlphaGo largely works. There's been more recent work that looks at more human-aligned models of expertise that say on average people might be searching around 5 steps ahead using some kind of handcrafted, potentially computationally expensive to compute values or features that you're using to assess any one board state. And this is in contrast to, say, other simpler models of search where there was some older work in the 90s that looked also at how kids are playing tic-tac-toe. Or say there's no search and simpler game features that you might imagine, say whether someone's thinking about whether they can win immediately from a move or whether they can block. And here this also ties back to the OpenAI example we were giving in the beginning, where when you're taking action in a company, you might be thinking about how does my action advance my goals versus compared to kind of blocking my competitors' goals. And then there's even more naive play of no search and uniform random play. So we're interested in something that's a little bit more in the middle for our novice model, but not at expert level yet, but what might be before that, which could be that you're doing depth-limited search with general game features. The Weiju Bass et al. Work had assumed that they looked at one single game and how handcrafted features might inform play in that game. But as we said, we have these 121 games that it's as even experimenters, you can't just easily create little value functions for each of these games. So we're interested in how people might have general game features that can say assess how far you are from the goal and how your progress compares to your opponent's progress in the game. And we have no search, yes.
As someone who's not familiar with these models,
yes,
is what drives these sort of theories mostly based on the fact that they're based on cognitive constraints that we had at the beginning when we were willing to expend only so much energy, or based on some notion of having a belief or biased belief that certain way of winning a certain arrangement is a winning arrangement, and that essentially precludes us from looking around and basically zooming out to see alternatives?
That's a great question. Yeah, so we are proposing that people are reasoning in a more computation-bounded way when they're playing games for the first time. But I think what maybe is your question asking whether that's an active choice that you could search further ahead?
Right, is it a bias, an active bias, or it's simply a constraint?
That's a good question. That's a good question.
That's fine.
Yeah.
If you don't have an answer.
Can I ask a related question?
Yeah.
Is the theory of cognitive, sorry, I've always wanted to ask somebody this question. Is the theory of computational constraint that you're choosing, that humans are using, is that essentially the theory of computational constraint that I would sort of attribute to, like, the compute power of, say, NP hard, like algorithm? Is that the same construct, or is that a related construct, or are those just different constructs?
I'd say they're related. You look like you want to say. No, you're right. I'd say that they're related constructs, where then the theoretical techniques for analyzing computational constraints in, say, the NP.
But it's not the same thing.
Not necessarily the same thing. Yes.
Yeah, so maybe also I think that's an excellent question. Maybe also plan a flag for like a later discussion, because I think it's also related to like the kind of general also according to computational theory, like even Bayesian update is really intractable, and how we humans try to do some kind of very smart kind of approximate kind of heuristic kind of algorithm that allows us to do that. I think that's definitely related. But I think partly here is any of this kind of very deep search algorithm is essentially NP complete or NP hard that is just infeasible for humans to do that in any kind of finite amount of time. So it's part of the kind of really computational question is what kind of representation or kind of approximation algorithm allows people to do some of these things. And also maybe tying back to your question, I think there's two different but related concepts. One is the representation of knowledge of your knowledge about what's a good move and what's kind of winning condition, and also just the raw kind of ability or resource and how hard you are willing to think or you can think. So we think that if you give people, say, like 1 hour to play a game, then they can definitely search harder. But the knowledge, there's a lot of rich knowledge already there when you hear about the rules of the game, but that's kind of maybe the more interesting part of expertise that you develop over time.
I think there's a fundamental difference as to whether you're allowed to have a computer help you or not. Right, that is, when we start talking about NP hard and things like that, we're talking about we need computers to help us, right? And algorithms. On the other hand, if we're just talking about raw cognitive power of a person without a computer to help, 5 steps might be the most you can do. If you've got a computer to help you, you could look 100 steps or 1,000 steps or 10,000 steps, right?
Yeah.
So are we talking about naked person without a computer or well-equipped person with lots of computational power?
So far, this is the naked person, so only human. But we do have a slide later on of
I'm not sure that's the analogy you want to go with.
human AI partnerships. I do think that.
But as I understand it, I'm sorry, it's just, but I do think it's sort of like.
Yeah.
So when I think about my little brain, right? And like sometimes I think questions are really hard. You'd be surprised at how simple they are, right? But sort of, and I think Josh has worked on that, right, as well as others. They don't, right? What's weird is that the things I find most difficult are some of those are things that computationally are actually quite easy, and some of the things I find most easy are precisely those things that a computer would find hard. And so that kind of tells me that those two things are different in our current architectures. But I don't know when we write down a model and say, I have a computational model, I have a computational cognition model. Is that model essentially drawing directly from our models of computation and saying, let's see if people behave that way? Or is it drawing from some model of cognition and then using a computer to calculate it? Or is it doing neither of those things? And if that's a bad question, just say, Scott, move on.
No, I think that's actually a great question, where I'd say if, say, Tom Griffiths were giving this talk, his group is definitely in the camp of the former, where they look to CS, read CS textbooks, and then try to apply them to problems in cognition. I'd say, you said you can characterize, but I think Josh's group tries to do a back and forth in a little bit of a different way than, say, using tools from computation and CS
We're willing to go,
then inform.
for this evening, it's all Josh's group.
Okay,
so that's,
well, they're both in
that's
the
right
yes,
answer.
Josh, yeah. It's, I'd say it's more of a back and forth where then you're using computational tools,
but
machinery.
also it's a debate within, so you're saying,
It is.
Because I think for the more social scientists in the room, right, we get one step removed of all this, and it's just the person, right? So we'll hear I've heard different cases at different moments, and I'm now realizing those are cased, not like orthodoxy.
Yes, I'd say it's case. And I also think that there's then a crosstalk where new insights from cognitive science can then also inform new computational techniques, including especially on problems of programming that we'll talk at the very end on.
I can add something also on that, Scott. I think some of the roots are because there's various flavors of learning theory that are sort of broadly generalizable to all of these. And so that's where the taking from the computational formulation comes. But exactly what you're pointing out is there are some problems which seem easy for people and hard for computers is actually often exactly the selling point that people like Josh will say is like, why do we study this area? Not only to use the computational side to understand cognition, but also are there problems that are easy that can help us to understand how we can improve our algorithms to perform better. And that might be leveraging, at least from what other arguments others have made, all of the sort of optimization processes or learning, development, evolution that are baked into us to make it easier. How can we sort of port some of that maybe into the algorithms that might improve their performance and allow them to.
And that's pretty much the inspiration for neural networks, essentially in the 70s and 80s, to get inspired by human brain in order to develop artificial neural networks. Is that sort of the same analogy that how?
It is, although there are, I guess, still debates ongoing as to like how much did the neuroscience really, contribute to the computational part, and how much is one side to the other, and how much is one back. But yes, generally that's kind of the idea of like maybe there are some useful analogies between the two.
Yeah. And last thing I'll say is that I think for a future talk, I do think human AI partnerships, the systems that both meet our expectations and then complement our limitations, are definitely very interesting to study that could bring together cognitive science, behavioral economics, and AI. But for now, so getting back to our model, the key proposal here is that one of the ways that novices might go about, or someone encountering a new game, a new system of role and reward, is that you're doing some kind of depth-limited search, either no search or just a little bit of look ahead, using general game-based features that help you reason about whether you're making progress towards your goal by your action, and how that action might also block the progress of another agent and their goal. And together, we are proposing, and what we found empirically, is that this kind of model generally captures how people are reasoning about evaluating and now playing, as we'll show a little bit later, these new games. And this will be clear, I think, as we go through the empirical results. So again, here, this is kind of our overall framework, is that there's, we can think of how someone might evaluate new games that they've never played before by combining this compute-bounded, depth-limited look-ahead, potentially even zero search, with generalized value functions that assess whether you're making progress and whether you're blocking. And that you can then simulate forward using this kind of model to then imagine different actions that are taken, and use these with potentially few, though we're still looking at the exact number, led by now, of how many simulations you might be taking to then, and whether you're even going to the end. You might not even need to simulate towards the end, and kind of just do a little bit of simulation to then assume or make an assessment that a game is likely to be fair, likely to be unfair, likely to be fun. And what we see is that this does generally capture how people are reasoning about the predicted payoff of these games. So we first look at how people can predict outcomes for new games. This is the payoff question. Again, as you mentioned, we have people estimating the predicted payoff of these games. We have many hundreds of people doing this task. And what we see is that if you then run simulations under our model for each of these games, so each of these points is one of the 121 games. On the y-axis are people, and these are the standard errors. You can see, as Scott was saying, that disagreement is endemic to how people reason about the world. So you do see some disagreement, but generally, our model of depth-limited look-ahead with these general purpose value functions is very well capturing how people are reasoning about these games. Sorry, yeah.
Okay. The red line, is that okay, so.
Red line is identity.
Red line is, yeah. Red line
that's
is
the point
identity.
No. So the model, the estimated payoff, so what's the actual payoff that's not represented there?
The actual payoff, you mean the optimal payoff?
Yeah.
Good question. So we compared to several other models. We have, first, some of these games I believe don't actually have an optimal payoff that we can easily compute. We used a Monte Carlo tree search based model, which can act as an approximate, though definitely approximate oracle. For many of these games do have exact, either definitely second player has an advantage, definitely first player has an advantage, definitely would end in a draw. This is then compared to people here. So you can see that people are not predicting in the same way that an optimal computation would, or at least a more expert. And we've compared that to several other.
ET4 doesn't do so great when they have to get my money back.
Yeah, no, it does not. And again, this is great where the measure of success is predicting how people perform. So that's a key aspect also of computational cognitive science, where the goal is to capture human behavior. And in this case, our goal is to capture novice human behavior. This might be very different if we had people, gave them, as said, an hour to think about it, or if they played these games for 200 trials and then did these assessments. So that's a key on the metric, yeah.
Can you say again, what's on the horizontal axis?
That's like the model.
Yeah, so this is whatever the model is, where the model, we got different,
Each game is played n times by the computer. It was played by humans, and then basically the points are the model's prediction relative to the humans.
Yes. And crucially, people here actually did not play these games. They just looked at the game, thought about it, where they were given a scratch pad that they could click on, and then play, because we have play later.
Sorry.
Yeah.
I volunteer for moderator, and just for the context, we were discussing about whether Bayesian entrepreneurship is normative model or positive model. But in this case, it's both, because the model is predicting what human behaves. Correct me if I'm wrong. Instead of
So that's positive.
both normative and positive, because
No, if it's just predicting what humans do, it's a positive model.
but the cognitive scientists are trying to explain why this is some
Yeah,
have some
but it's not saying
rationality.
what people, right, but so I think maybe this is maybe a presentation point, but I actually think because there's two things that lead the model, like the model is, there's an actual payoff here.
Yeah.
You know what I'm saying? I understand sometimes it might be hard to calculate, but
Yeah.
but just as kind of the first thing you would want to know is, does the model, forget that it's trying to predict the human for a second, do humans or models predict the truth in any regular way? Do you see what I'm saying?
Yeah.
Like, how well do they do in predicting which which games are biased towards the first player versus the second player versus a tie, for example. Then the second thing is condition, because the problem is that curve is being shaped by two things that are varying across the games. One of which is what is the right thing in fact to do. Do you see what I'm saying? Like, what's the actual payoff? And the other is the ability of the model or the human to predict that.
Yes, that's a great point. And the closest that we have on this slide, though certainly, I think there's about 80 of the 121 games that actually do have an optimum we can tell you. This is the closest you would see to humans, but you're right that we should also show the intuitive theory of games model against this model. This is the closest that we have so far, but then if you did.
So just to even push it, just losing. So relative to something that's a little closer to the truth.
Yeah.
And I might be misinterpreting this. The true distribution of payoffs is much more flat than the estimated distribution of payoffs for both the computer and the human.
Flat being.
Because basically the.
I see, yes.
You see what I'm saying?
Yeah.
Like essentially what that's saying is, we just tilt it a little bit more.
Yeah.
That's sort of saying like across all the games, it's kind of big flat line. That sort of says, you see what I'm saying?
Yeah.
Right?
Yeah.
Or, well, I'm trying to, I know because that's what the humans, I have to think of it.
Maybe one kind of like more point on this. So I think maybe it's helpful to think that I think like for most of these games, the kind of ground truth would be either just -1, 0, or 1. So there will be like a no uncertainty and their optimal play for most of these games. And for some, it's kind of like a non-solved in the sense like chess is non-solved. But for some that can be solved, I think like in many of them like the player one is favored because you play first.
Okay.
But this is a strictly positive theory of how human decision making works. In other words, you are not concerned with the truth. You're concerned with what kind of model aligns with human learning process the most.
Yes.
Okay.
Yes. Great.
Let's let you go. Right, but interestingly, so yes, but I think in this, well, I've already been calibrating to the actual payoff, which I understand now is mostly in fact discrete. It's kind of like interesting to know, like, what are the circumstances under which there is a best outcome, it's like 0, 1, it's like always best to be 1. Under which case does the machine know that? And which cases does the human know that? When do those three things go together?
Yes.
And when is there a divergence? So it's kind of like you want to, those three objects, I think we want to think of every outcome as that triple. Do you see what I'm saying?
Yeah, that's a good.
I'm not sure, but at least for me.
Yeah, that's a great point.
I mean, it's really interesting. Let me just be clear.
So that's an issue. So what you're saying is, depending on what that picture might be different, depending on what the expected outcome actually is.
Yes.
Okay, that I think is very interesting. It's still a positive theory, but it's sort of
right, because that's as it relates to the normative point, because you want to write the game.
Right.
Yeah, that's a great point.
Is the Depth 5 search full game simulation the one that's kind of saying this is what people don't do because it's so flat? Do I have the?
Yeah.
How do I interpret that?
Good question. This is what past CogSci work says that experts might do. We're here, again, we're asking about novices, which has been less safe. So it's kind of trying to also highlight that existing cognitive theories of expertise don't apply to when people are encountering new problems, which you might think is quite intuitive, but has not been explored as much in this space.
I see. So basically what it's saying is that, say when the model is at 1, that's like saying, the depth 5 search would have said that this would have been one where the first player would always have an advantage. But humans did not really have that because it's about 0.
Yes.
Is that right? Okay.
Yes. Josh is reading.
Yeah, I think Josh might be here in like 10 minutes.
Okay, that's good. So I can go through quicker so that we could have full Josh when he comes. So from this we also asked people about how fun they think the games are, which has quite high subjectivity, but we also can have a model that can predict it. So our approach here is that we then take readouts from our intuitive theory of games model, where then we can kind of simulate play in this model, and then assess the expected entropy and other components. So first, I'll show, we asked how the relationship between how someone's fairness judgment of the game relates to how fun they think the game is. And here, this is predictions of the entropy of likely game outcomes under our intuitive theory of games model compared against people's funness ratings. Again, what I'll show you here is that we'll walk through a few different components that we think might be in play with what people are doing or thinking about when they're determining whether a game is fun. This is also very active development, sort of open for conversation. To walk through what this plot is showing, each of these is one of the 121 games. Y-axis is people's funness ratings. Point is the average funness rating. Error bars are the standard error. This is then entropy over win, loss, draw under our intuitive theory of games model. We see that it has some...
Wait, entropy is equal to what?
Entropy over the...
What is the definition of entropy?
The channel entropy of kind of like a measuring the variation in the distribution by bits. So you just like you take the log of the probability distribution.
The log of the probability distribution of winning?
Winning, losing, and draw. So
yeah.
Perfect. Okay, that's all I need to know.
Yeah.
Okay, fine.
Great. So you see this has some component. I'll go through each of the components for the sake of time, just each of them. Then we have another component, which is that you might think about not just how fair this game is, but is it a reasonably challenging game? Because hopefully for many of you who are at MIT, but what is fun is also having some challenge that you need to overcome. So here, the measure of challenge, and this is again credit to Sed, is looking at advantage of how likely you are to win against a random agent, and how this corresponds. So say that if for a game where, or our idea is that if there's a game where you have really no advantage over whether you're going to beat a random agent, then that game might not be very challenging, because a random agent, if you just think, or you don't even need to really think, you can just play randomly and have a good chance of winning. So this, we think, has some factor into how fun a game is, and also how long a game takes. So this is the expected game length under our model compared against people's average funness ratings. We see that this is not linear, but there's some kind of relationship between game length and funness. That really, really short games might not be as fun, but then super long games, there is kind of a tail in drop off in how fun you think a game is. There also, and we kind of built a regression model that combines these to get an average funness rating. I'll just go through each of the components and come back. Then we also think that there might be some relationship between how fun a game sounds and how this then can kind of combine with these other slower simulations that you might do in your kind of actual model of the game. This will come back later when we talk, if we get time, talk about innovation and creation in games. That you might be combining kind of fast as a sound like a fun game, say, drawing on your prior experience with games, which LLMs kind of capture pretty well, with then these more structured components. When we take these all together, we get generally a pretty good regression model of how fun people might find a game. And as this relates to entrepreneurship, this could tie into kind of your assessment of, say, a new situation or a new game, of then, or a new system of reward and reward, and whether it's likely to be engaging for you to participate in, to think about. Because I imagine part of what a good entrepreneurship life is kind of having fun doing what you're doing.
Interestingly, we also abstract away from that, except in my office. I have an equation on my board that makes that point.
On the wall.
What?
Is it on the wall or?
Yeah, on the wall.
On the wall.
It's been up there for 10 years. If you can solve it, I think you win a Nobel Prize. But it's really hard. It's very easy, but it's very hard.
Yes, we're very interested in, and I think games are a great place to
whether or not
study
people
funness.
think they account for their time, and they might account for some objective they have, but whether or not they are, how they think about
economists find it very difficult to think about the choice that an entrepreneur makes to spend their time in entrepreneurship and the activity of it versus the money they make from it and how that relates to their outside options. So we can spend, maybe not this evening, but.
Yeah, but I think when Josh comes, that actually would be good. Yeah, I think so. It's less than 10 minutes now.
Yeah, around maybe 5 minutes.
5 minutes. Okay. Okay. I think it'd be good because it would be good to have Josh for the full discussion. This would be something to discuss of funness. Then I'll briefly talk about extending this to think about how we play in new games we've never played before. We've talked about having this kind of agent model that does depth-limited search with these general purpose value functions within this kind of system to evaluate these new games or new systems of rules and reward. But how well does that underlying agent model actually capture how people play? So what we did is ran a new study with 320 participants, crowdsourced participants on Prolific, where they each played 6 games against each other. They played just 1 match of any game. And they also could, they could have made actions on the board against each other. They'd play to the game ended, or you could optionally request a draw from the other player, or choose to surrender. If you requested a draw, the other player had to accept your draw for the game to end, otherwise it would continue. And if you surrendered, the game would just end immediately. We're really excited by this draw and surrender data too, because it ties into kind of when you choose to quit or stop a problem, which also ties in to entrepreneurship. When do you decide that what you're doing doesn't work out and that you should just move on? And this totals over 930,000 human choices in these matches, so it's one of the largest kind of data sets of these new games, so we're very excited about that. What we end up seeing, and this is good thing Josh is back here, he's not a big fan of these bar plots, but if we then look at the aggregate move likelihood to say the probability that our model assigns to you playing your move, where we're comparing this novice intuitive theory of games model, which again does depth limited search with these general purpose value functions, against that expert model, the kind of past CogSci depth 5, and against the random agent. Generally, lower is better here. I won't walk through this too much, but we are seeing that generally the novice model better captures human play than experts. And we can look at this we ran this for 40 of the 121 games. And what we see is that generally across these games, the novice intuitive theory of games model better captures play. And this is people play just 1 match in 1 game that they've likely never played before. Then captures better than compared to expert and random with some important deviations. 2 crucial games I'll show you here that our model does not capture people's play as well. One is in tic-tac-toe. There, the expert and novice model are much closer. If anything, the expert model is a little better in some perspectives. And which makes sense, people are not likely novices encountering tic-tac-toe. And the game is also a smaller board. And then any of these win inversions, these kind of 3 by 3 in a row loses, or 5 by 5, 3 in a row loses, these games, our model does not yet capture how people play in that, so that's an open area that we are looking at.
Game or something?
Yeah, that people seem to play much more randomly, but also it seems like there's some structure if you look at how people are playing, so we're trying to think about that. Yeah, so there's successes and failures of our model as of now, and then what we can also do is look at these, for each of the 320 participants, we can then fit kind of mixing weights for these 3 different components using an admixture model from genetics to see kind of how much are the moves that you played in these 6 games better fit by any of these 1 models? And generally across, so this is the kind of 50% mixing weight. Most people are better fit by a large component of the novice model, but in general, people are also fit by, we got some people that are better fit much more by expert, others with random. So there is quite a lot of diversity in the people who are playing these games.
So just to understand, a vertical line here is a assignment of a player to the basically what percentage of their moves or something
are better fit by any of these.
I'm weighting some likelihood function with the 3 models, and then everybody's getting 3 parameters of the weights. That's interesting.
Yeah, so this is quite cool, and again, it highlights the variability.
Is that hard to do?
We can do it with kind of optimization, but it's not too hard.
Okay.
Yeah. Yeah, it's a pretty cool analysis. Credit, Josh actually suggested this one. And then, as I mentioned, that we also can look at when people decide to stop playing.
Yeah, I think he's on his way, but it's hard to.
It might not be 5. It's kind of a hyperbolic discounting of time. The last thing I'll say of this data that we have, this is also really credit to now. We can also then look at when people decide to stop playing. So this is preliminary. We're still analyzing this, but we can. This also ties in, as I said, to when should you quit the business, start afresh. How are people making decisions to stop? So you can look at people's choices of when to surrender. So there were on order of 60-ish instances, I think, of people surrendering. And then we can look at, under our intuitive theory of games model, simulations under that model, how likely is it that from the position that someone said that they were surrendering, how likely is it that they would have lost? Was that decision that they surrendered under this model sensible? Where generally what we're seeing is, this is density of, on the y-axis, generally people, when they were surrendering, they were at a board that they were going to lose under our model. We need to compare this to the other alternate models that is currently running on the MIT cluster now, those analyses. But generally, people seem like they were sensible under our model in their choices. Similarly, we can look at the people who, as I mentioned, that with draws, you could either, the other player could either accept or reject the draw request. So we can look at what was the likely outcome under people who requested or who accepted or rejected a draw when they were requested. People accepting the draw request, outcomes under our intuitive theory of games model generally were likely to end in a draw, or the games where someone accepted. That board under our intuitive theory of games model was more likely to end in a draw. The people who were rejecting, the boards were generally ones where they were still had some probability of winning under our intuitive theory of games model. So under the intuitive theory of games model, people's decision to reject or accept seems to make sense. Again, we need to compare this to the alternate models to see whether there is the right sensitivity, specificity. But one of the analyses that we're working on now is to see, are these decisions to either quit or accept an end early sensible under what you might think the game would further kind of continue towards. So this is ongoing work. And then just as a refresher, or as a summary, what is our intuitive theory of games? Our idea is that there's kind of this simple model of action choice that is faster, computation bounded, with general game playing concepts, this idea of goal progress and blocking, and that you can do kind of simple, approximate probabilistic inference over these outcomes by simulating play. And this could tie in, which maybe for the discussion of kind of what actions you might take in the early stages of encountering a new business, and how it impacts or relates to how you might decide whether a business is worth starting or whether to invest in a business at all. And what I won't talk about now, but we have bonus slides on, are actually having people watch games too. So one of the things that's interesting about business, as you were saying, Scott, about Shark Tank and VCs, is that we also can either suggest action someone should take, say someone on the board of directors suggesting something to the founder or a CEO, without actually being the one who's taking these actions. So we've run a new study extending on these 121 games, where we have people watch movies of other people who've played these games, and then we freeze the video at various time points, and they suggest where someone should move. And we also see that this novice model well captures how people reason when they're novices where they think someone should move. I will very briefly just show one last thing, which is kind of that we also don't just take games that already are out there and play them, or start the same business over and over again, even though that sometimes is profitable. We also create new games and new businesses. And this is early stage work that we actually have first iteration of the work in CogSci in this coming summer, where we're looking at how people create new games.
Just make sure you can get back up.
Yeah.
Okay, yeah.
Okay, this is good because we have about 5 minutes left. And so now we're trying to study innovation through the lens of game design. This is earlier work, so right grounds for conversation.
Keep on going.
So what we did here is we gave people the goal of creating the kind of game invention task of creating a game that's fun. This is in that same study I was telling you about earlier, where people were evaluating games, we had them, after they had rated these 10 games, then spend at least a minute creating your own games. You could type in any game, any board size, any win conditions, and we asked you to make it fun. And what we end up getting is a big data set of 480 of these created games, human innovations, some of which were drawn essentially from that first bank of games, and others that were new. So here's a bunch of these games that people had written in. Someone wrote in each player, 10 by 10 board, each player has 3 lives, 3 in a row causes you to lose life, being reduced to 0 loses produces you lose the game. Another where you have to get 4 in a row and yell floofy, else it doesn't count. So people are pretty creative. But there are also a lot that also kind of recombine from the existing data. So our key point here is that how we create new games is both a mix of the role of context, of what you've seen before, and also evaluation. So here we can use our intuitive theory of games model kind of in the loop to evaluate these new games. This is on context, I won't go into that too much, but we basically see that there's some portion of people that are, oh, Josh is here, that are drawing on what they've already seen, and then many others who are creating new games. Where the role of evaluation comes in of, here we can then think about using our intuitive theory of games model as part of this kind of creation evaluation loop. And I think this also might be a good part as Josh starts to settle in. Yeah.
So we'll give Josh a few minutes to get, so first can we give you, this
thank
your
you,
last
Josh.
slide?
Yeah, this is good. I'll end
Well, well, just getting ready, and any other comments? Let me just maybe make one or two, or maybe let me ask you a question, if that's okay. So, as it relates to, this kind of entrepreneurship, but particularly this kind of Bayesian, the specific granular of this Bayesian approach, is that if I, so let me go 2 steps back. I love this idea that one part of entrepreneurship is essentially people are inventing a new game in some sense, right? That's a way of thinking about innovation, and it's a nice analogy. It's not the only analogy, but it's a nice one. And they do some amount of recombination and some amount of recombination from things that no one put the word floopy with game design before, and so that's a win. Okay. On the other hand, when you're thinking about, I'm going to spend the next 5 years of my life on venture X, I sort of want it to be something where I think, so there's this nice thing that actually came from one of these podcasts, this unfair advantage, right? Like, I have a theory of the world that's different than other people's. I have some belief that I'm a pretty good match for that theory of the world, and moreover, maybe for my interest or maybe for what I think will be its large profit, I go out and spend the next 5 years grinding it out, however I did. And I'm trying to think of how that, is there a player, so that's, I think, a little bit different than this, where, it's almost like, there's one part in the theory in this kind of game where, like, if I'm an expert and I go up against, occasionally you'll run up against an uncle who will take money from children at games because the kids don't know how to play, and then, he says, I'm teaching them a lesson, and it's just, you're like, what a bad uncle. Okay, that's my Uncle August right there. Okay, right, there you go. There, okay. Or you could have something, but I don't think that's what it is, right? It's more like there are these people who think they know what they're doing, but there's this other way of playing the game, or another game, however you want to think about that analogy, that turns out to be, at least under my theory, is going to be a better way of playing. So is there any, have you done any work here that looks at the heterogeneity? So this was more about mean results, rather than looking at the conditions that supported more or less heterogeneous approaches to even the gameplay itself.
I think that the slide that we were talking about where we were looking at
you might have gone
admixture was a good case where we do see quite a lot of heterogeneity in people's playing, where there are some people who their moves are better fit by a more expert model, where we're really looking at a spectrum of expertise.
Right. This is right. So this is how those models relate to what they did. What they did. Right.
Can I jump in?
Yeah.
I think what this is really getting at is like Settlers of Catan issue, right? Like, that's an example of a game that's a lot of people like to play, including some entrepreneurs we know.
Yeah.
And you can have different strategies, right? And most of these games aren't quite rich enough to be like this. But one of the things we've been thinking about is looking at games where there might be like what seems like a default strategy, or a naive strategy that the naive model might do. But there's some other strategy, maybe, which almost corresponds to a different game, right? That if you can play that strategy, then you can win against a lot of people. You don't have to be a super smart person. You just have to have had that one insight, potentially, right? I think that's
So
it's not really like think more steps ahead.
So
it's that you have a different strategy.
80% of people
like a different game.
80% of medium good Risk players will all talk about how it's all about Australia. So, right?
Oh, Risk, yeah.
Yeah. So Risk is similar,
Yeah,
right?
that's crazy.
Right. Everyone believes it's right. But in
Yeah.
fact, both computationally, as I understand it, but also some people will not do that.
Yeah.
There's an old, right, even the very old Axelrod book, right? Right, so which was, where they played the first game where they simulated basically Prisoner's Dilemma. Again, people played many rounds of Prisoner's Dilemma, both against each other and against computers.
Yeah.
And it turns out that if in a repeated game, everyone else is playing tit for tat, there's in fact strategy, what I'm saying, if everyone else is doing that, there are very profitable other strategies that sort of screw those people over and are very beneficial to you. But it sort of depends on everyone else playing tit for tat, which is sort of what you're getting at, right?
Well, that's more interesting than what I was getting at, but I'll go with that.
Yeah.
No, I mean, I think, again, part of the dynamic that's really interesting in human strategy, and especially in entrepreneurship, is, sort of recognizing, when there's a strategy that is good because it dominates the strategy that everybody else is playing.
Yes.
Or just recognizing that there is a strategy that is more efficient or just better, and other people haven't realized it. And I think what's especially interesting is, and a thing we've wanted to do, but haven't really done in this work yet, although maybe in some of the games here, is like basically to study a game which is rich enough that within that game, there's effectively different games you could play. And some games, or like some of the deck building games people like to play, I'm a little bit more familiar, I don't really play any of these games, but this game called Dominion, anyone play that? Right, so Dominion, like there's different strategies that people play, and like, I'm gonna go this strategy or that strategy, and I know some really pro Dominion players who they just like to make a random Dominion game where they deal out random cards and then think about and talk about how they would play the game but don't actually play it. Because they just try to expose that it's like the meta game.
That's my wife's strategy.
Okay.
She wins everything.
Yeah, okay, well, anyway, so I think, I think we haven't looked at that in this way, but I think we could, and I think this paradigm is one, maybe it's one people here are interested in.
I think it'd be really neat to know if novice players could look at a game and have a sense that this is one where you could become better, like it was a rich game, or not.
This comes in a little bit to our funness modeling of then how challenging it is, how much reward you might get for thinking relative to a random player. But that is a good question.
Yeah, you can even imagine forcing people to bet and say look, you'll get to play 10 rounds of this. How much better do you think you're going to get?
We've talked about running something like that, but have not done that yet. The closest we've come is having people watch other people play, and then you make similar judgments about how fun you think this game is overall, how likely it is you think that it'll end in a win, loss, or draw. It's a great idea.
Have you encountered any situation where the experts have a different perception of the richness of the game than the novice? In other words, the experts find the game almost trivial to the point that, and they're perhaps biased because they know it so well. And I've seen this among seasoned exited entrepreneurs a lot. When I talk about my research, they're like, this is way too complicated. We don't think that way. This is very straightforward. And then when I actually collect data and look at their behavior, sometimes I can find patterns that speak of a much richer sort of. So I wonder if there is also the situation where the experts have sort of a different perception of the richness of the game, which contributes to the extent to which novices will be exposed to learning the rules of the game or developing strategy.
That's a great question. We've not looked at experts specifically in these games, but even in these games when we have people kind of essentially we're treating them as novices, they've not encountered the game before from within our study dynamic, that we do see individual variability. As I mentioned, that my intuitions about these games are usually quite a bit weaker than said and now. So people do come in with different levels of expertise, but we've not yet had people say, play a game 10 times and then make these judgments, but that's in our next docket of things.
Yeah, and maybe just one quick example of something like that. So because we have some games where either the first player or second player can go twice at their first move. So in some of those games, you could actually, if you're an expert, you can do the kind of winning pattern that if you set up the game the right way, you'll definitely win. But most people will just do the more kind of naive thing, maybe just make two pieces in a row, but not the winning configuration.
Right. Because I think that has implications for normative theories of entrepreneurial learning, for example. If a bunch of experts don't think everything about, or most things about entrepreneurship are trivial, not that they find it trivial, that they don't think it's something that can be taught in the classroom, for example, then that's an impediment to learning for
Right,
for
right,
the-
right. That's an interesting one. So just to kind of give context, right? There's huge debates in entrepreneurial education on what can be taught and what can't. Which, which I'm not gonna bore you with, but are a very large topic, which I have a view that most people don't. But very often, people will find areas and say, this can't be, you know what I'm saying, like.
It's learning by doing.
Yeah, it's learning by doing it, right? And to be honest, most people have, and then you sort of make an affirmative case and you get back and forth. But your point is that actually, when do people have good intuitions about what is a learnable, teachable skill in the domain of novel problem solving? Right, I would think that's I think that's what you're getting at.
that's
I think that's a really, I'd be very interested in the answer to that question, because I don't know.
When is the right answer mensa manus and when is it veritas?
Yes, exactly. Okay, with that, actually, that's a very good, so Josh, thank you so much for joining.
Yeah.
And I think are you gonna talk a little bit about what you do, or how should we?
I mean, I could if you want. I just thought I was gonna join the discussion.
Okay,
on
okay.
this, But,
Okay,
I mean, because this is what I do. This is.
okay, very
Yeah,
good.
this is-
lab.
Okay, great.
And-
So why don't you go,
But I mean, but I'm happy, you can ask me
These are
anything,
some
whatever
points
you want,
that,
or if you want me
Can we have you sit at the table?
Why don't Lisa,
Oh yeah, I think that's, I won't go back into slide, I think,
yeah, come on, keep there, yeah.
I got a chair for you over here. Oh, you
I
don't
mean,
want, okay.
I should say also, Katie and I have just, one of the reasons I asked her to present here is I thought this work would be of interest and
Yeah,
it's valuable.
totally
to us. But also, we've talked a bunch about ways that we think this might connect with the entrepreneurship world. So I don't know if you discussed that yet, or maybe that's what you're
this
doing
is,
now.
yeah, it was
Okay.
motivated through
Yeah,
that lens.
yeah, so really keen to talk about that as well.
So I have endless numbers, but maybe we should, yeah, so let me make one or two, is that useful to start with one or two comments? So I think there are two layers here. One is relates specifically to Bayesian entrepreneurship, more generally to entrepreneurship, right, and innovation. So it's definitely the case that one of the main challenges to do systematic studies of entrepreneurship and innovation is what, so I started with this old quote from Canaro. If you have a theory of novelty, you haven't thought about the words theory or novelty nearly hard enough, right? Just a very, right, because that's what we're trying to do. And because specifically what you're trying to do is get a sense of what people can figure out, like as real human beings, in roughly real time, so that a single human being or small group of human beings can have a very outsized impact by doing novel things. And that has to do with how they quickly assess an environment. You're not quite as quick as, more than 5 minutes, but less than, heat death of the universe, so somewhere in there, right? So they have to be able to assess, is this a valuable thing to do? And how can they orchestrate assembling resources, testing, experimenting, and actually making commitments that actually don't go from zero to building real firm. And so I guess maybe this is to all of you, the researchers in this area, is one is kind of a piece about, let me just try to synthesize this, about what do you think, so relative to a traditional economic model, so let's start there, what would people get wrong about how people understand the economic environments in which, novel economic environments? So that's one of the big, so this is a group, the non-Eurolab part of it, that sort of is trying to think a little bit and trying to reason through how do people, relative to the traditional shared priors, highly rational economic model, how do you even have a, which let me be clear, struggles to have a theory of entrepreneurial opportunity and innovation itself, right? Because outside of government giving out the grant to the entrepreneur, if it's there for me to see, it's there for everybody to see, how can there be rent to the whole thing? Do you see what I'm saying? How is it that you have a constructive theory that's somewhat computationally feasible, you know what I mean by that, you can write down models, that allows us to think about that process of creating novelty, either in innovation or creating new organizations that are profit-making in terms of entrepreneurship. So maybe that's.
I guess I have two thoughts.
Yeah, great.
Is it okay to
Yeah,
jump in?
yeah.
Or a couple lines of thought. So these also relate, computation of these relate to some other work in our group, which I thought about talking about, but then I thought, oh, this would be good, which is the memo stuff from Kartik. Did you guys talk about that or cover that? Because if you're interested, we could try to do that in another week. I don't know what your schedule's like or some other time.
There's a traveling roadshow.
Okay. Well, again, one of the things that I guess is like, it's a version of what you said before, the sort of classic question that entrepreneurs are asked, typically by investors, what's the thing that you know that nobody else knows that you can get outsized value from, something like that? What's your asymmetric advantage?
Right.
And that's a good question. That's the right question. But I think there's a deeper version of that, frame for that, which is relevant to what we're talking about, which is like when somebody's thinking of starting something, or a group of people, a small group are maybe starting to together, they have to say, what's the thing that we know that nobody else knows, that we know nobody else knows? It's important. You have to know that nobody else knows. And you have to either know, or this relates to your experiments, you have to either know that it's going to be valuable, or have a thesis on how you could test its value and de-risk its value in a reasonably efficient way.
Yeah.
Right? So I think these are the kind of things that actually some of the tools that our lab has been developing for kind of recursive reasoning under uncertainty could be relevant for, or that we could try to even write down, like if Kartik were here. So Kartik Chandra is a colleague of ours who's developed this new probabilistic programming language called MEMO, which stands for metacognitive modeling, I think, and Katie's used it a bit.
Yes.
I don't know if anyone else here has used it, but it's really cool probabilistic programming language, and it's been used already to model a number of classic sort of theory of mind things, recursive mentalizing, K-level reasoning, various Bayesian games, and so on, as well as other phenomena in kind of computational social cognition. And I think if Kartik were here, he could write down in an hour or two, basically a model, a little toy model version, something like this. So another reason I asked Katie to present is I know she's pretty interested in the entrepreneurship world, and Kartik is a little bit more ivory tower, but but anyway, we should go and take a look at that, and might be interesting to try to write down a model of first, how could an agent, I might start with one agent, or maybe you could have the negotiation between two agents, but in a group of a couple of other agents, basically rationally reason about that there's some key state of the world, maybe, let's say, or something about the dynamics of the world, or the value of some move or something, a thing that they know that nobody else knows, and that they can at least make a good bet that it's going to be valuable, or that they know something or they believe something which will let them de-risk the bet to decide if they should invest a little bit more to invest more. And I think that's totally reasonable. I mean, so at least as a kind of proof of principle toy model, I think we could model that reasoning process. Part of the challenge is it connects to other classic challenges in metacognition and AI and computational science, which is a lot of our metacognition, and I mean metacognition in sort of a more general sense. So if I use the word metacognition, that you may mean different things, but I mean broadly.
Can I go back to my little brain?
Sorry.
No.
Going too fast.
No. Okay. So what you're saying is, so it's very hard outside of asymmetric information, pure models of private information, to have a model where not only do I have a secret, but I know you know what I'm saying, I know you don't have it as well. But what you're sort of saying is I can have a theory of I know something and I figure out that you also don't have it. What would be, just kind of give me I'm trying to understand if that's an informational difference between us or a cognitive computational difference between us.
I think most importantly,
what are the,
most importantly,
because it's a really interesting question.
Yeah,
so what would be the things?
I'm just trying to channel what I know about different entrepreneurs and investors. I think many people are looking for someone who has like some informational difference, because like cognitive differences, there's a lot of smart people out there. And if you say, I'm going to win because I can think one level ahead of everybody else, maybe Dennis Savas or Sam Altman could do that, but very few people could do that. That's not Elon's strategy. Let's just say, I don't know, whatever, I'm just, okay. But
That example has been
Or I don't
ruined
know,
for all
or
of us.
maybe I have some, you know, I don't, it could, I mean, there could be multiple sources of it, but I think fundamentally there could be multiple ways that you could come to know something that nobody else knows. Or.
So let me give you the example that I think is just because it's both canonical but also helps think. So there were a group of people at the Homebrew Computer Club, of which Steve Jobs and Steve Wozniak were two, but that wasn't the full club. There were like 20 or 30 people in that community, maybe even 50, right? And like Bill Gates of all people, right? And was aware of that club and wrote them a nasty letter about free software and things like that. Okay? Very funny letter. But what's interesting is that Steve Jobs and Steve Woz, the difference between everybody, so it'd be fair to say that all of human society did not understand the impact of microprocessors in 1975. You know what I'm saying? It was not a generally known thing. Or even if you read about it in the news in some vague sense, you wouldn't have appreciated it. But everyone at the Homebrew Computer Club had exactly the same information. They all got the same computer kits. They were all aware of what was happening at Intel. They were all aware of basically the ability to somehow take these things, and they were all kind of putting them together to create simple interfaces. And the difference between Wozniak and Jobs and the rest of them was that Wozniak and Jobs sort of knew that everybody else in the world didn't know and that IBM was going to be hopelessly behind. That's right.
Yeah.
But they also somehow took this thing that all the other people of the computer club took to be just fun, like what we do on Wednesdays. And they're like, actually, I'm going to quit my job, right? They're like, I'm going to quit my job and I'm going to ask people to pay money for this thing that we currently do for free. And maybe that's not the only example, but it's nice canonical, right? And what I'm trying to understand is what's the model I should bring.
And I think that also ties into something that we've talked about of people have different tolerance for risk.
Yeah.
And that also ties into entrepreneurship, that some people are okay taking risk, but then you're more okay making a bet where there's higher uncertainty compared to someone else. And I think that could be one factor.
Right, though interestingly, and maybe this is, I don't want to oversell on Steve Jobs here.
No, I like
He didn't think it was, for him, it was just, there's this famous example of entrepreneurs actually don't think it's risky.
Yeah.
Because they think it's a sure thing. They are seeing.
Yeah.
They think, there's a separate point about risk, but they think they're seeing the future.
Yeah.
And the future they have to create, but they think they can do it because they're confident in themselves, maybe. But then they're like, oh, this is actually not risky. It'd actually be riskier to just sit at, some mid-range, what were those called? What's that called? It's like a middle size.
Middle management.
Yeah, right. It's just risky to be a middle manager because you're gonna get fired by the Doge.
No, I like that. I mean, I think, again, I maybe I'll change what I was saying and come back to this. Another word that I feel often gets used in entrepreneurship, but a little bit from a distance, is like your theory. What's your theory, right? So the right word isn't maybe knowledge or even belief, but theory. And now I think another thing we work on, and some of you might know, or maybe it's been covered here, is like, cognitive scientists talk about intuitive theories. What are, they're scientific theories, but it's a part of the bread and butter of our field and our lab is building computational models of systems of thinking that individual or groups of people have, which are kind of like scientific theories, but we call them intuitive theories. But they're like scientific theories. They make predictions, they explain, they can be used for value, power, and they can be tested. So if your theory is right, you should be able to do an experiment. Like that informal way of talking is actually, in cognitive science, we would say, oh yeah, that's exactly the right way of talking. So maybe what's needed is to couple the sort of things we've been, like you're talking about here and what we might talk about in these metacognitive models with, a little bit of intuitive theory building, where somebody says, well, it's hard to really know something that nobody else knows. But you might have a theory that for whatever reason, other people haven't come to, maybe because they didn't see some facts you had, or maybe because you did think through.
They lived a different life.
Yeah. If somehow you have a theory,
if we face a new situation, right, like the computer, right? The fact that I haven't lived the same life as you, by construction, my theory is contingent on the life.
Well, maybe that's one of the things that cognitive scientists work on is how No, many people could live different lives, but all come to roughly the same theory. But not always. Like
Right, that's, so the notion of the intuitive theory is.
If Mendel hadn't seen those peas, he wouldn't have his theory of genetics.
Right, yes.
No,
Yes.
if Darwin hadn't seen the finches on the Galapagos and so on.
John, you had a question?
Sorry.
Well, I was thinking, if you
We're
were
more
trying
of a
to-
comment phrase things, I think.
Well, I was thinking of this like idea of like you know something that other people don't, and I was thinking in the context of the games you're playing. You know, imagine you had people and they had to select into which game they want to play, like A and B, and they can read the description. You could potentially like endow someone and say, hey, we're going to spot you 3 moves with an AI. So when you play this game, you're going to be super powered, and you know this, and everyone else does it. Does that affect what game you select into?
That's a great
That's
example.
really, yeah, that's a great, yeah, that's a good idea.
Because for some games that gives you an advantage and others it doesn't.
Right.
Yeah.
And then you could probably give like a common signal about how many people have the superpower versus not. But you know, I mean, I was thinking about like this idea of when do you know that you have private information? One is that you've done the fundamental research yourself, which is sort of like, you know, if it's something like hard tech, like, oh, I did this, I know I can commercialize it, and I know that I'm ahead by this much. I mean, it's kind of a nice theory of why so much of it comes out of universities, right?
Yeah, that's a great point and idea. And yeah, as you said, we do have biased games, so there's some games where 3 moves ahead from the AI system is not gonna help you move. 3 moves, yes.
But what's interesting actually was right in this, so we, about a year and a half ago, we had this conference here, this Bayesian Entrepreneurship Conference, and we had, mostly it was, you know, economists and some, or economists and other social scientists. But we had Nubar Afai in here kind of on the Saturday morning, and he kind of led a discussion of the, you know, interesting work that he's done, right? And he was on this board over here, and he had this actually very interesting point, because he has this like, you know, the work they've done in Flagship is very proactive about nailing down this one thing. And his belief is they do this big, long survey of basically what do people in the field believe are the adjacencies of the blocking spots. You know what I'm saying? Now, these are in fairly hard tech areas. Then they do a round. It was really interesting, right? Tell me if I get it wrong, right? A few of you will hear it. And then they do a layer where they tell people, you know, it's on these various advisory boards that they have. They say, for a second, imagine that constraint that your field believes in does not exist. Like, I don't care, no matter how much you believe the constraint exists, for the next 6 hours and we're paying you for your time, don't believe that. What would be the implications of that? You know, suppose I relax that constraint, what would happen? And then they get reasonably good predictions of what would be feasible in particular areas, conditional on that. And then they use that to do bioengineering around those problems. Do you see what I'm saying? Like, yeah. They realize that, oh, it turns out, because it turns out, and he said it, if I remember this, it was very interesting. He said, sometimes it turns out that you say, oh, what's the constraint? And people will say, they relax it, but it turns out not to be very valuable to relax because it's still a total disaster.
So they try to build the tree without
Yeah,
knowing.
and then they put, and because they have a big fund, they're able to put reasonable effort, you know what I'm saying, into specific areas. And then he had some good examples. He had something about some crazy kind of plant oil or energy, I couldn't remember, it didn't work, but most of the time it did, and we all got it.
You know, that also seems relevant.
Yeah.
Like
Yeah, with math stuff, yeah.
Yeah.
But, so which
The math.
Oh,
math-
yeah, or just
We've talked to a lot of
yeah.
mathematicians too, who then also have shared that their process is partly adding constraints, removing constraints to a problem as you go about solving it.
There's a lot of interest, probably many of you know this, but just to put it in common ground, a lot of interest right now in AI, in mathematical reasoning. It's become the place where the state-of-the-art language models are supposed to show everyone how smart they are. I think it's kind of the new chess, right? I mean, AI has consistently made this mistake of identifying like, what is the smartest thing that the smartest people do, or the hardest thing the smart people do? It used to be like chess and Go. Now it's like, you know, a math Olympiad problem solving, or even like proving theorems. And it's true that some really smart people do that, and it's really hard. But I think I'll just say, I think it's only, you know, one of many problems. But it happens to be one that, like chess and Go, you know, there's a right answer, or like you can verify, like if I claim that I've solved this problem, you can check. Or if I have a proof and it's a formal system, there are these formal provers. So it kind of has the same properties as things like chess and Go, which make it good for somebody who wants to scale up some big AI system with reinforcement. That's just sort of a footnote to say why a lot of people, including us, are interested in mathematical reasoning. It is an interesting area of human thinking, including like we study even like how fifth graders think about math contests. And it turns out problems that like some of the latest OpenAI systems that like score some of the very top scores in the country on the hardest math contest for 12th graders are barely about chance on contests for fifth graders. So that should make you think. But we've been working, Katie's been working with some of the world's most brilliant mathematicians actually to study games that are like math problem solving. And so really interested in that because it has similar things. And they will often say, well, how do I change the game? Or can I imagine that this axiom wasn't true? Like, how did we get non-Euclidean geometry? Suppose the parallel postulate wasn't true. What would you get? So it's part of why we like mathematical thinking is it actually has a lot of creativity to it that is in common with, say, entrepreneurial or other creative, value creation. So anyway, I like that idea. But we can try to.
And I want to open it up more broadly. I have one other comment, but maybe if there's other comments, or I know there's like all things going in many directions. Let me ask one more question, then I'm sensitive that we're over time. But I want to go back to your intuitive theory point, and I know there's another colleague you have to, right? Right, so I love this topic, right? Is it the case, so you said sometimes people iterate to the same intuitive theory, and sometimes they would persist in having different intuitive theories. What do we know, or maybe we can follow up with Angie and others to help, is what do we know about that? Like, what are the dimensions of variation of that problem that we know about? Like, when is it the case that a group of actual human beings will all end up believing the same thing about something, even if they've never discussed it? And when would it be the case that they faced this novel situation that they wouldn't even know, this analogy I give, I love this book, what's it called?
Umwelt?
Yeah, the Umwelt from this,
book?
Yeah, I love
Man's
that.
World, yeah. I mean, that's the popular book that popularizes it.
Yeah. And so,
it's a good book.
It's definitely a good book to talk about at a different party. That's what I'm talking about. And even this. Okay, but when is it an Umwelt problem that literally people talk past each other when they face these situations, which is I view as the variation.
Yeah, I mean, I think so. A simple thing to say is that's oversimplified, but one angle on this is one that some people here will be familiar with. I think Rothwell especially is. Broadly in the Bayesian cognitive science or Bayesian epistemology world, that the same issue comes up all the time. Like people study polarization. Like, how does it happen that if you think everybody's like approximately Bayesian, or if you imagine a group of Bayesian agents, when would it be the case that people maybe who see different data converge on the same thing? And when might be you have a case where people who are seeing in some sense very similar data converge to different things? And how does that depend on your priors, and also again like various hierarchical models about how you interpret even the source of the data. Sometimes people will model things and say, well, if I think that the data is biased in some way, then that might lead. Yeah. So I think the way we approach these intuitive theories, like most of the other stuff in our lab, is as a kind of Bayesian inference. So we could say, well, like again, this is where that some of the technical contributions that folks in our world work on is to say, if we think that human inference and learning can be thought of as a kind of approximately resource rational Bayesian process, then one of the challenges is how do you get that to work with interestingly structured representations, interesting kinds of models of the world, interesting hypothesis spaces of hypothesis spaces. So the stuff about probabilistic programs, which you guys have heard about, I think, or okay, those are examples of these are programming languages for expressing Bayesian inference over intuitive theories, right? And that allows us to do things which are probably fairly familiar to some people here, of like doing the kind of Bayesian analyses of the questions you're talking about, but on these things which are more like intuitive theories and not just like the weight of a coin or the probability of climate change, or what's going to happen to the stock market if we pass a lot of tariffs or whatever. Sorry.
If I may close up with one question, what do you find in your own domain, your own interest, what is the most interesting set of questions that you're currently working on at the intersection of cognitive sciences and Bayesian statistics? like regardless of whether it has a flavor of entrepreneurship, what makes you wake up in the morning and jump out of bed and go?
That's a good question.
Me personally, or
You
personally,
personally,
yeah.
yes.
Well, a lot of them are these ones. I know that's, I mean, basically the ones which look like, or generalizations of some of the things we're talking about here. So, and maybe I'll just also extend the theme of what I was saying a few minutes ago. Do you mind if I give you a 3 or 4 minute answer to that?
Absolutely not.
3 or 4 minutes and then we will clap
Okay,
and then we'll be.
So I'll tell you that by saying it's sort of like the latest chapter in a story that I feel like I've been living, reading, helping to write for a while. Like why do I do any of this Bayesian stuff? I think, or what's motivated it? You know, everybody here I assume is familiar with Kahneman and Tversky and behavioral economics, and it's bread and butter, or it's just like apple pie. You know, this idea that like there's sort of that's a famous chapter in a very long story that goes back before Bayes, at least, maybe to Pascal, maybe to earlier thinkers of like, what is the nature of human thinking and rationality, and how do we make good guesses and bets about the world? And a lot of work on this question for decades and centuries has been a back and forth on, you know, is it like, basically, are we sort of basically rational, or which it's going to look something like probability theory and utility theory, or some tweaks on that, or do we need something else? Because there's so many places where either simple notions of rational inference and decision making don't seem to be right. They don't seem to fit with behavior or what people think, or people seem to do some special thing, or they seem to be intractable or impossible. And that has led people to come up with various tweaks or hacks and things. I mean, or minor tweaks like prospect theories, minor tweak on expected utility, and other much more major things. And that includes both utility theory, probability theory. But in my view, the math of rationality is right. It's the right math. We don't need other ones. And in some sense, human cognition is best understood through a lens of rationality. We set the gold standard. You know, there's a reason why it doesn't matter how advanced AI gets. Like we're the ones who the standard of intelligence is the standard of rationality as we have laid out. Like the notion of a rational agent, that is an intuitive theory. Like the early economists came up with that by trying to basically sit in their armchair, because they didn't really have much data, and reflect on what would be a consistent mathematical description of basically our intuitive theories of belief, desire, psychology. And some of the work that people like me and others have done in our field shows that even young children, even like 10-month-old babies, even in some form 3-month-old babies, but more quantitatively 10-month-old babies, have what we've called a naive utility calculus. They analyze the actions of others in terms of costs and rewards and expected effort. So like in fact, that is like a very deep within us model of behavior, and we have it because it's basically right to a first approximation in a lot of cases, but it's missing many things. And what we see it's missing is all the stuff of computation. So that could include data structures and algorithms that make things tractable on large scales, but also, for example, the data structures and algorithms that let you do approximately Bayesian inference and decision making about things that seem like, wow, I didn't think you could be Bayesian about that. Like you said, Bayesian statistics. I almost never talk about Bayesian statistics. I talk about rational or resource rational or approximately rational, belief formation decision. But when somebody says Bayesian statistics, I think of like, okay, well, you've got this hierarchical Gaussian model, or maybe there's like conjugate priors, Dirichlet multinomial, or something I could write in Stan or whatever, or R. Like statistics to me sounds like, numbers with fairly simple, a simple vocabulary of distributions out of which you compose some
without enough
hierarchical
tweaks, essentially.
Yeah, or like a big, hierarchical linear model, and there's people like Nate Silver who do like really powerful things with that toolkit. But and really push it. But I think, human thinking, what animates cognitive scientists, and the work that's animated me, is where this sort of broadly Bayesian view and computationally realistic Bayesian view makes contact with the stuff of thought, cognition. So that means things like intuitive theories. It means things like thinking about games, problems, and it's what we're always trying to do is sort of push the boundary of what are the most interesting parts of thought that don't seem like they fit into that toolkit, or maybe don't seem like they can fit into any computational or scientific account of the mind, and see where we can fit that in. So all the things we're talking about here, novelty, like how we think about new situations, how we think about how we might change the game, right? So it's not just about, like, again, both statistics and standard, I think it's a lot of standard psychology, including a lot of standard decision making, is like, the game is given to you, you just have to make the right decision. But what makes entrepreneurship interesting, what makes science interesting is like, no, the game isn't given to us. we can think about which game we play. There's a vast number of games. We can think about how we might change the game. We might go look for a game which has certain properties to it, or we might hypothetically or counterfactually, well, suppose the game were different, and what other games would be different, or what other games would that unlock? So that kind of thinking is an example of where we are interested in our work, and I often wake up many mornings and send Katie or Seth a text like, well, what's the latest on my project, or so we're animated by it though, but it's because it's a place where we're pushing the boundary of our ability to build formal computational, really scientific theories of the human mind into places that it seemed like they were too hard, right? And where we could sort of talk about it, but not really make it what we would call, in the School of Science, a scientific theory, or what we might call in the School of Engineering, like an actually machine executable piece of code that could do the thing that the mind and brain does and maybe get machines to do it. So that's what we do over in our science and engineering is that broad process. And so it's these kind of creative problem making, not just problem solving activities that are one of the main things that are key.
Thank you very much. Thank you for
Okay, very good. Okay, this is quite a, thank you very much all, and thank you
so much.
We're just going again in 2 weeks, so I'm not even sure, I can't even, okay, we're gonna have Alexis, right?
Yes, in 2 weeks, in 3 weeks.
In 3 weeks?
Yes.
Okay, we'll get an email on that. Thank you all. That's very good stuff.
Oh,
Very good.
I also feel like
My name is Amir.
That was a really good idea. We talked about problem choice for nature, but not actually studied it. And not looked at it. Yes, here until April 21st. And then I go back to April 21st. And then I'm back.
So this was,
Thank you so much. Your opening talk was awesome. So I took so many notes.
Well, I'll send you the, so, yes, this is what we're, I think it's kind of, interestingly, it's better than it used to be. This group forced me to actually be more clear. So that's some of it's the same, but it's really great to have an opportunity. And I thought it would be good to sort of see it from a lot of different angles. And I would say,
no, actually, so
I've been meaning to tell this to all of you.
He's been part of the team.
So when I was a kid, famously, because I grew up in not a place with protocol, that's a school. They used to be kind of fun. I used to play, not against myself, coming back and shoot,
That's actually
and lose. And that's a defiance. That was for many years. That's what my parents went to the school. They were like, that seems to be a little bit of an oddball. So, either way, I will say, one, if you were up for it, I'd be happy to, really very interested in entrepreneurship. I'd be happy to sit down with you a little bit more generally. I don't know, are you already here or are you
So I was just saying, I'm here until April 21st. Then I go back to April 21st, and I'm here from
So let's, I would love to chat with you. I have many things to, I'd love to learn more about what you're interested in, how we could, depending on what your goals are, what to get more involved in. If you are interested in entrepreneurship, there's nothing like a pandemic to write a textbook, so we did that. But that's also a good introduction. It's very accessible, but it's also it actually turns out to be not a terrible introduction. Which is different than just the Bayesian entrepreneurship paper, which is in some sense a very narrow line on trying to convince people of this approach.
Yes.
So, but that having been said, I would love to talk more, and I thought both the work is very interesting. I would say
I think many years ago.
that interestingly, you got to it,
So in the wake of that.
I would really into a people from
a lot of
economics
public, I guess, by discovery. Like a lot of people.
Not with the
did a lot of
like
like
myself,
economics, text and social networks.
so they all whatever, but I'm talking about
I realize maybe others want to.
Yeah, exactly.
Math and also
But
like.
to an economist, I would say, and I'm happy to work on
It was really interesting.
Thank you very much.
Sorry, I was late.
Amir, my name is Amir.
Questions of how you play against others. And the level of how would this be a good game? Like there, for example, there's just because I was gonna say this, but you read it.
Alright, okay.
For example, there's some games that are fun to play against others, and there are other games that are not fun to play. I'm sorry, fun playing against better people.
Yes, yes.
You know what I'm saying? Like, and always, like it's actually quite boring to play, Risk against somebody who doesn't know how to play it, you know what I'm saying?
Yes.
But it's actually, there are all sorts of games that are interesting to play, and then there are games that allow for handicaps.
Yes.
And that people sort of go by the honor system, so basically it's actually interesting.
What do you
Right,
think?
you know what I'm saying? So just having that kind of general theory of kind of,
Like, I think we.
and the point being, that gets closer to this question of who you're competing against.
Yes.
I'm literally like.
Yeah, there's a lot. That's a good, a really good
So,
You agree that
they would be way more balanced having this sort of.
And in fact, arguing that people mechanism sucks. These basic constraint being super important.
It's on the fun question too, there's a really good quote in 2001. Well, the scientists for how would handicap itself to make it fun for the astronauts to play. And that was one of the motivating quotes we had with it. Our goal is to have people of different expertise.
But I also thought that this machinery
Models of
theory
push in that direction. So would that be?
like you have to really decide that you want to study very specific
Clarification of the kinds of questions.
I know, I
the idea that people are
I'm gonna say thank you to Jeannie as well.
right, this notion that people come into the world and I know, right, this whole example I gave.
So you build up from.
And I think I've just gotten much better from this group and saying it right, which is
But I think that's
a shared priors are not
aligned to those.
right, they're just really, there should be, if you believe in purpose of human behavior, I
Well, that
should,
would be interesting. I mean,
if
work on that.
John is willing to sell me an asset, the first thing I should update, if it's a common value asset, is Milgram Stokey all the way. He's telling, he's got private information. Right?
Yeah.
Yeah, the stock market nonetheless opens every day.
Literally
Right?
founder versus.
That's part of that. And then part three though, is if you're facing a novel situation, right?
But they just have
There's
different
no
roles.
reason I would know
But no, but I
John's
mean,
theory.
again, one of the.
There are many examples, and so I that's a very,
And,
and it seems like there was
a way to
something
take what would.
Yeah.
would-
in what you were doing where you could study that.
and make it work.
This was great.
You know what
Yeah.
you
And
you know what you
Move for investor and founder together, so even just studying that process, like how do you go?
You don't know the rules, like with some probability it's this game and this game, and then you play and then you update with your.
And sometimes.
Yeah, there was some previous slides that had where you could then guess.
More
That's actually
That's
my great
having
nightmare.
people guess
Yeah.
what game someone's playing, say if you give them.
Right, and you get,
set of
right,
rules.
what
It's a really good idea, like, here is our different
the ultimate game is the
distribution
one where you
about
have to figure
markets
out.
groups.
That's
And how
that's
well we
the
can actually
short
do
version,
this.
right?
Yes.
It's
And
the
perhaps maybe you're
many
using this part of
different pieces
distribution
of it, but I
for
thought
deciding not to
that
invest in me, but if we somehow
yes,
show
and
like if we hire one
understanding,
person.
and also what's
so I can
inaccessible.
scale much faster and then
So
perhaps this level.
so that's a
maybe
little
we
bit of
actually
a
can
return structure, like the games where you had to, what was it, you couldn't get 3 in a row and people found that.
Yeah, 3 by 3 or say 3 in a row.
Right, right. So one of the very interesting entrepreneurs, there are certain kinds of entrepreneurial opportunities that are sort of, what I'd say, available in principle even today. You could run an exercise, you can convince yourself there's a gajillion.
It's very hard
You know what I'm saying?
All that too.
But it's sort of like
Yeah, are you,
zero humans,
are you
like,
working in
like
this area?
the
I mean, I know
essence
you
of
do.
entrepreneurial
Like,
activity is
because
a small
sometimes, like,
human
you're
beings
good at
have to be able
Definitely,
to
it's
do it.
exactly.
Yeah.
Gives them so like, in other words,
Exactly.
you know,
The thing is,
Maybe this is
see what I'm saying?
for us to collaborate on.
And
I feel like
it turns out, maybe it's just
you're a really valuable bridge,
computational
obviously.
understand
You know
that.
this, but
You
of course, it's
Yeah.
really
You see what I'm
valuable.
saying, like,
The whole world of
that-
computational science.
the relevant constraint, it was in a way that you guys think like, that's that what I'm an expert in, like,
Arvin, yes, that's
So
what I know, that somebody else knows, yeah,
This is
so.
exactly,
you know,
Help you or work with you.
so a very
this is
famous
honestly
version of
exactly
this
what
problem.
I'd like to do.
It's
Thank you for
very,
the
very
last
hard
session,
Yeah.
we had
for
the
entrepreneurs
paper with Tomer
to
on,
see the global implications
Oh,
that in the
on
era
this
that
stage
is
to reading list, and I think I should point out,
like it's
Can I
thinking
ask a little bit
about
of the definition?
yeah.
Like
Like,
how
you
many
know, like people will,
Exactly.
inventors are terrific at describing the concepts. You know, this is, some of these quotes are apocryphal, but this is the IBM.
So you're talking about this.
Yeah.
1510, the army moving, when the Navy moving, there was they're coming to the man was, that was the element, you know.
Is,
they're gonna shut,
scientists
and even,
what are the
Yeah.
spaces
the thing is, some things are sort of hard for people
really
to
like,
reason
we're not sure
about.
exactly
Yeah.
what's
In
going
some
on.
situations,
And you think
and
about
some
different theories.
people are like, it's Uber for chickens, and they
And also
totally
where those
understand.
representations even come
Like, I can tell you Uber for chickens,
kind
and
of
you sort of get the sense
canonical
that we're doing
scenarios where the representations
distributed
are so
chickens
complex.
somehow.
Like,
Only
as
after we
we're
introduced the
defining what
concept
game
Uber
is,
into the language,
and
that's
play with
also
the action
one thing we didn't show.
here. And that's
Yeah, actually,
why
Sharon
I'm
Alvarez
not
was so much.
synthesizing.
She's very big, I mean, she's that,
To me, I completely agree.
she's very big on
It's
this
very
language,
exciting.
like,
Yeah.
all new industries. Her claim is that all new industries, not a new industry,
Amazing knowing
unless you have.
I guess I'll be there for a little bit of that.
You were,
but I have to.
And I thought that was like an incredible claim, I thought it was probably not true, but I sort of, Sharon Alvarez, she's more like a
Great.
real master.
Katie, I wanted to thank you so much for making.
You mentioned, I've heard you say nail is scale of failure.
Well,
First one I come to.
there you go.
Those are really good. We have this career right now that we can do that.
Very good.
It's we see us at a form and have those, but I can email you.
Through the,
Okay, yeah.
oh, really? Okay.
I can write it down.
I was gonna say.
I actually have a very good story.
Oh, that's even.
I was gonna guess that,
Thank you.
but I didn't want to.
Yes, those are really good.
I gotta go, but I just wanted to say you're welcome to join.
I have another process here, and you want to just theory, turn into the comic. Yeah, I should start that because of
Yes, I am.
You've got one on structure models of entrepreneurship and another on how computer fields kind of deploy the US. It's gonna be a social application.
No, I didn't mean something. Something I figured you knew.
Those are really good.
Really
Thank you so much.
Thank you.
Thank you.
We should get you a copy of our other book.
Thank you so much.
On Bayesian entrepreneurship.
No, it's implicit, I'll send it. I'll make sure it's signed.
Okay.
We can also get Bayesian, so we separately have to file, for MIT press on Bayesian entrepreneurship. I think it's a pretty long essay with a bunch of us, and then there's like 10 copies.
Yes, we can send it.
Which is sort of, yeah, and it's sort of one of the things that it has is, what's the name, is how do you design experiments?
Yeah.
Like, in
I did
how do
when I
you
was actually
balance different types of
undergrad here.
You're like de-risking an entrepreneur.
Yeah, so like, if I'm presenting an opportunity, how do I de-risk it, and how do I do that
next year.
Depending on the
Yeah.
timeline.
And how do I do it? Yeah, nice to meet you.
Yeah, I sent you
you're
an
like-
email.
Oh, thank you.
Yeah, we'll chat.
Yeah, exactly.
Thank you so
Were you
much.
also on the faculty?
This is a, though you definitely, this brought out,
I am,
which
yes.
is the goal of
Yes.
this group.
So exciting.
Very interdisciplinary, like, we got more people across the school in this room than we usually, you know? So I think that's good, thank you. This is.
Yeah, we started trying to sell PhD students.
Yeah, well, we should take a picture.
That would be good to do more of that. I mean,
That's
I
like
love
it's,
it.
I mean, like,
yeah,
yeah.
depends on
You know, I
like.
think hiring this guy was good. I remember actually,
Thank you so much
I'm pretty sure it's in this
Thank
one
you.
for Dave Brand's job.
Yes, yeah. David loved this stuff, yeah.
Yeah, that was good. And I
I
was just gonna say to
if Zoom is
comment on
okay
your
for the
conversation.
three, but if not, no
Years
worries.
ago, I gave a
That'll
talk
be
at
in
the
English.
Booth School.
If
Yeah,
not,
they're
I fly back and forth.
behavioral
Yeah.
decision.
Yeah.
Okay, thanks. Yeah, definitely.
I mean, I know we do, but I think they, at that time, that was like 10 years or more ago. Anyway, I think that
not
building
really-
a increasingly rich community
Very good.
of people interested in
Yeah, and there's
thinking about
some
decisions.
Yeah.
And across, I'd
No,
love
no,
to be
and-
part of that and help.
I
promote
have to
positive-
admit-
Somewhere, it's going somewhere, but
Alex
love
emails,
Yeah.
10 summers.
Yeah.
I mean, what I would say is.
I'm not saying you don't, but we did
No,
build
no,
up
no,
more
no,
of
no,
the
oh,
center.
no, 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 no.
And
I decided, so I did this group, last year, it was on a very different topic, it was on basically networks. David actually, the little time about innovation networks, it was actually on like network theory, and sort of like, it was on, it was basically, you know, Ben Golovitz? Who's an author.
It's in his moment right now. He's all about.
He's all about supply chain resilience. Yeah, it was Amy Finkelstein famously said about Ben Golovitz, if anything Ben Golovitz does actually relates to the real world, I would view that as the greatest surprise in my life. No. Her husband is Ben Old. He got
my wife used to work at Amy.
Oh, yeah, no, Amy is, but
That's Ben Old. I thought that was a cute, you know.
Interestingly, well, there are many densities like Jones, who, right, but Ben Gold. So the key part though is, I've actually decided it's a very weak, to be honest, it's something I got out of the habit of, and it's just having a visitor, I mean, who has an interest, and then organizing a group around it that's sort of very informal, and people can kind of come or not, and then we get some people who are interested or not, you know, and with like some, but like more specific than like rando talks, but less specific than like, you know what I'm saying, like, oh my God, we're gonna talk about
reference back.
yeah, and just, yeah, and the talk I gave was a lot clearer than the talk I gave 6 weeks ago. So,
Very good.
there you go. That shows that I'm making
I know
some.
some people host visitors specifically with that goal. So it's a good strategy.
Yeah, well, no,
invite
I'm-
visitors, like come for semester, we'll organize.
Yeah, we'll organize a topic on this, and I'm one of those people, and but I gotten out of the habit of it. But really totally fascinating. The other thing I will say is that understanding the cognition piece. You know, this example, once again, I don't think it's representative, but I think it's canonical, which is this Jobs and was within a medium of other people. All of whom were ambitious. See, the thing is that they weren't like just, you know, smoking LSD on the side. These were relatively people like them. Right? If you look at the history of this, it's a very funny observation.
Yeah, no, I like it. I think, I will think more, and I'd like to think more about this, because I think the different, with you guys, the different versions that you said, whether it's that part or it's like, you know, how much machine or suppose this rule didn't, suppose we get people to pay for this thing, that right? Or suppose we had this thing and you didn't just do it for fun, but you used this as the basis for the business. And that, and then, you know, part of this is actually kind of slightly deeper thinking, which is think, okay, it's like what Mike was trying to make figures, but a way of thinking. Say, okay, yeah, well,
My sense is
these things are different.
That's like the direction where I want to take, but
And
there's
I was
like
So anyway,
how do they identify what is a good thing to think about? Like, what's a good candidate?
So
that's like the kind of thing really.
like a pathway.
I have to tell
Now
you,
it's
too,
like-
I'm pretty sure Newbar
like,
thinks he has a lot of
I mean, that would be
ideas.
tremendous to look
Newbar
at. We've also,
Newbar-
one of the
Newbar
works that we
fine.
didn't spoke about here is
Who is,
modeling
you know,
language.
and Newbar is
kind of
super
trying to
smart, you know what I'm saying?
So he just thinks.
I think interestingly, no, they do invest.
Remember Elizabeth, she said back,
They-
she took our kind of ideas from and she's also an expert.
Yes.
So basically, years of work. So they hire these people.
These are like
They-
entrepreneurs.
I want to talk to them.
No, they're full-time employees. The weird thing is, it's once again, he changed model all the time. His own model going back to the late
If you're interested.
I'm not sure if I'm gonna
Really
be at the
bad
UN.
Nickel.
Yeah.
And his belief was that you would hire these divergent thinkers.
Think very, very
Right into like
Yeah.
frustrated academics
And
who
all
had a
those
good
things
business sense and everyone thought were a little too
Here's
complicated.
something
To solve that for other people. Right, like he has like a type, you know what I'm saying? And you would hire that person, and they somewhere, you were there, I mean, I think
We'll
this
see how it
is.
goes.
No, it was like,
Yeah.
And then you
Yeah,
say,
it'd be great to talk
and then
about
they
it.
form this like advisory
Yeah.
board of more traditional thinkers. But then there's this kind of, and then you train and the people that you're hiring, yeah. And then basically, and then he's made that a repeat, so what he says is you shouldn't use the word entrepreneur, you should use the word entrepreneuring. And the idea is it's a process. And he wrote a little, actually, he wrote the foreword with Fiona Murray for the volume, yeah. And it was, it was actually very, I mean, I will say, as somebody who's known Newbar for a long time, but even more specifically, has seen him in the classrooms and whatever for many, like when he was a teacher. He always had this as like this crystal, like it was always clear, but he just did a really good job of like finally explaining how he thought about risk, how he thought about uncertainty, how he then put resources to bear to kind of, do the stuff that made Moderna and, made, but also 45 other companies. It's been a reasonably successful little venture.
Also emphasize people face.
No,
I'm gonna write it.
Yeah, so I think, the other part is this
I
whole.
was gonna say, I know about flagship, and that's very interesting, and the way you explain the theories, I'd love to learn more about that, or I wonder if he'd be interested.
There's a great, I can send you our student, Josh Krieger, who's at HBS, wrote actually a really good, I think it's Josh Krieger, wrote a really nice case on electrical science. Yeah, but we'd be happy to get you, thank you guys so much.
Thank
This was
you.
really fascinating.
Yeah.
I hope we can find more opportunities, or maybe someone said, maybe it was the visitor, Amir was his name?
Yeah.
He said, come back and, I guess, you're having you have a structured plan for the next 2 weeks?
I was proposing inviting him for the social planner session because Josh's group has a group prior, using a group prior, how to plan that with a theory of.
Yeah, you mean like theory of
Well,
just keep me in the loop, right?
Yeah.
I'm happy to chat off in some smaller capacity or join you guys more later.
Yeah, so let's see, I mean, well, let me let you go. Many things to discuss, it was good, this is a good
Thank you so
stimulating
much,
time.
thank you.
And now I'm going to somehow figure out how to get dinner. Okay?
This is good.
The,
That's the other.
I know how to solve that.
My
Business
intuitive
and
understanding of that, this I'll get you connects to it.
Thank you again.
Yeah.
Where's
Thank
the
you.
cooker?
Thanks, Scott.
Thank you, guys.
Thank you.